So very good morning to everyone. Welcome to the AWS Cloud Practitioner Training Program organized by DevOps Hub. DevOps Hub is dedicated to manage, design, deliver, and transform large-scale enterprise solutions, focusing on DevOps, site reliability engineering, to improve efficiency of an individual as well as an organization. This program is dedicated to all the people who wants to start a career in cloud computing. So we will go through all the details of the certification, how you can appear and how you can write. So I'm Priyadarshan here today, the co-founder of and managing director of DevOps Hub. I carry over 15 years of experience in the IT industry, and by passion, I'm a cloud and DevOps coach. I have Ankit Saxena with me, who is going to be the primary speaker today. Ankit, over to you.
Thanks, Priyadarshan. Hope everyone is able to hear me. So, good morning, everyone. And while we were taking a break, I could see people who have joined from Singapore, Australia, Sri Lanka, and of course, USA. There could be some other countries as well, but these are the things which I could note down. So, I am Ankit, and hello all, everyone. I am cloud solutions architect for AWS. I have 15 years of experience in IT industry. I am currently working as principal technical architect for a SaaS-based product company here in India. And these are our handles for both Priyadarshan and myself. You can easily find us on LinkedIn or Twitter. Okay. And when I am not working, so I have my own initiative, which is like an Adopt a Family. It's a social cause which I run. So that's what I do when I am not doing IT. That's it. Yep. Over to you, Priyadarshan.
Okay. So let's quickly talk about the certification path. So if you see, AWS provides around 12 to 13 certifications, and the foundational certification is Cloud Practitioner. Once you complete that, you can go for either architect, operations, or developer. And the final stage in the professional path is the solution architect professional and DevOps engineer professional. Whereas the other special provided by AWS is about machine learning, data analysis, and databases, etc. Right? So this certification is CLF. Yeah. The CLF C01 examination is going to be the target for you after you finish this course. So basically, AWS Cloud architecture, what is the different services, what is security, what is compliance, and how the cloud economics work. That includes costs, how it builds, the analysis, and how the value you are going to get from AWS Cloud. So overall, all this will be taught you today. So the exam content will be, the exam that you are going to write will be with multiple responses. You have 4 options, or in some questions you will see there are certain multiple answers, so that you have to write. The unanswered questions or the incorrect, they will be just ignored. No, there is no penalty for that. So the total content outline from cloud concepts, you will get 26%. From security and compliance, 25%. And technology, overall technology means all the services. Out of that, you will get 33% of questions. And billing and pricing, you will get 16%. So like that, it will make your questions 100%, and you have to write the exam. The total mark would be 7,000 marks, and you have to obtain 700 marks out of it. So your score, you will only show you whether instantly you will get the result as pass or fail. later you will get a score, complete score of whatever marks you are going to get. So today's agenda, we are going to cover 10 modules for you. Introduction to Amazon Web Services, compute in the cloud, global infrastructure, networking, storage and database, security, monitoring and analytics, migration, and the cloud journey. How you start your journey and what are the benefits and what are the framework you should follow, the best practices, all those things we are going to speak today. So, Ankit, over to you now.
Okay, thank you, Pidarshan, for covering the introduction part. So we will be starting with our very first module, which is Introduction to Amazon Web Services. Okay, so I'm sensing that there is a time lag happening between when I'm switching the slides on my machine, and it takes a certain amount of time to get it reflected. So I'll be taking 5-second pause while the switch happens. Okay, in this module we will be learning three specific things. We will be trying to understand what are the benefits of Amazon Web Services. We will try to understand difference between traditional delivery and cloud deployments, right? And the third point, which is very important, which is the pay as you go pricing model. So these are the three things which we will be learning and which you should be able to easily understand once we cover our first module. Before going into the slides, I will just highlight that whenever on a specific slide, on the extreme top right corner, you see this icon which says concept. So what it means is that on that specific slide, we are going to cover a concept, and then we will be learning something about a service of AWS which requires the understanding of that concept. Okay, so that is how we'll be doing it. We'll be understanding a concept, and then we will then right away jump into the service which uses that concept. Okay, so to start with, we are covering some very basic concepts which you all definitely might be aware of. Just a quick refresher. Very first thing, what we are talking about is a client server model. It's a very simple thing. Each and every one of us experiences this. We can take a quick example of Facebook. It's a social media app, right? So when I'm using a Facebook application either on my browser on a laptop or on a mobile, then what I can say is, as a human, I am the consumer of that service, right? I am a client, right? But when we talk about in the IT or technology scenario, then the browser, right, on which I am trying to log into my Facebook or see my posts, that becomes the client, right? And then that client sends the request to a server, right? So those servers could be actual physical servers or servers which are sitting in the cloud. For example, Amazon EC2 server, which is AWS cloud machines, of course. So those are the servers which are fulfilling those requests, logging you in or giving you the recent posts, your photographs and whatnot, and then responding back to your browser, and you can see those content and interact with it, right? So it's a very simple thing. Client server model, it has we all are very used to it. Next up, again a concept, just very quickly breaking up what a server is composed of: CPU, RAM, and some data. So it's a central processing unit which is right inside a server, right? And then of course it has a RAM, and RAM is a unit in which instructions are stored, and a CPU pulls those instructions and then executes those instructions, right? And of course there is a storage layer. So for example, the hard disk which we have, or our SSDs, solid state drives, and all those things wherein we want to store our data, our files, or we want to install our applications, right? So that's the storage layer. And then of course we have the network layer, right? In the network layer, again a refresher, what is a network? I mean, it's a connection. It's an interconnection of different servers and clients which are connected and which are trying to achieve something, right? So how are they connected? They are connected through cables, through switches, through routers and whatnot. It's a very complicated thing, but for us to simply understand, this should be enough, right? Quick difference between a router and a switch. A router is a device. Today, nowadays, every one of us has a router in our house, right? So it forwards the data packets between computers and networks. However, switch is slightly more intelligent. It not only takes a packet and forwards it, but it has the intelligence to understand where that packet has to be sent to, whether it's a server or a client in the network. So that kind of a thing. So these are the very basics about what a server or a machine is composed of. It was just a refresher. Apart from this, let's look upon another interesting concept. Okay, it's slightly different, but again, it's an important one to understand, appreciate cloud. So that concept is scaling, right? Scaling is something which each and every one of us experience, not, I won't say every day, but yes, very in a very common way we kind of experience it, right? So if you talk about, for example, in India we have this e-commerce website Flipkart, right? So we all have seen big billion days of Flipkart, right? So what happens on a big billion day? The demand is so huge that the supply is difficult to maintain, right? So many people, thousands of people, they start logging into Flipkart website and they start purchasing items from there, right? So there is a huge demand getting created, right? So how do you respond to, when I say you, what I mean by it, how does the Flipkart organization, their people, the backend people, their processes, their systems, they respond to this increased demand, right? They have to scale up, right? So scaling could be in terms of, we would need more people because there are so many things which we have to pack and parcel and send it across, right? So we have to scale up, we have to have more people. In terms of IT, it could be scaling because you have servers and whatnot, so they are unable to meet the increased demand, right? So you need to scale up, right? Not only that, but also in our day-to-day lives, we all are using our mobile phones, we use our laptops. So eventually it happens that, it happened to me, I used to play when PUBG game came in, I had a very older version of phone, and when I installed PUBG on it, I wasn't very happy. The graphics were very poor, the game was lagging. So I had to purchase a new phone. So I scaled my phone. I replaced a lower configuration of phone with a higher end configuration of mobile phone, and definitely I enjoyed it, right? So it happens with each and every one of us, right? Two interesting things over here, which I would like everyone to pay attention to, which is a difference between vertical scaling and horizontal scaling, right? Again, basic thing, but I'm just asking every one of us to pay attention to this. So vertical scaling, by vertical scaling, what do we mean by vertical scaling is the process through which we give more muscle to existing systems, right? So for example, I had a machine, I had a laptop, let's say with 4 GBs of RAM and 2 core processor, and one day I am interested in doing high end graphics on it, right? So I replace it with a higher end configuration. So I go to a shop and then I get my CPU replaced, I get more CPU power, or I increase my RAM size. So what I'm trying to do is I'm vertically scaling, I am giving more muscle to the existing configuration, right? So that's what is meant by vertical scaling. Horizontal scaling, however, refers to that you, instead of giving more muscle to the existing machines or systems you have, you start increasing the count of those machines, right? So the earlier example, so for example, I have to package, I have to do packaging and parceling of, let's say, items. I am using 4 people, and suddenly the load increases, so instead of having 4 people I put 8 people, right? So I'm horizontally scaling up, right? So it happens with IT systems as well. I have a web application which is being served by two machines. Suddenly the load is getting increased, so instead of two machines I add two more machines, probably of the same configuration, right? So this is horizontal scaling. In reality, in ground practice, you would choose different strategies. Either you would do vertical scaling or horizontal scaling or both, depending on what challenge or problem you are trying to solve. Make sense? Okay. Now let's look at another important concept, which is the difference between a product and a service, right? So definitely, I mean, these concepts are not related, but why we are covering them is so that when we start talking about the challenges of what cloud is trying to solve, these concepts will help us a lot. So definitely there is a definition from Google. I will not go and read it. You can do that, you can Google it, but just again, it's a basic thing. uh, very good example which Priyadarshan gave me is like using electricity, right? So electricity is a service which we all are using, right? So it is something which I am not producing at my home. If that happens, then it will be a big problem, right? If I have to produce my own electricity, so that is something which I am not doing. I am using it as a service, right? So it's a service which I am using, right? Similarly, if we talk about in the technology world, if we look at the hardware, it's clearly, for example, I am using a laptop or I am buying a server for my organization, right? I am purchasing a mobile phone. All these are, we can categorize them as products, right? If we talk about software, yes, game I purchase, right, and install it on my laptop, it's a product, right? Software product. Antivirus software which I purchase, install it on my laptop or server, I use it, I manage it, right? So the key difference, what is happening over here, especially for software, because it's an intangible thing, right? So the key difference is, for a software to be called product, is I purchase it, I run it, and I manage it on my own, right? So the antivirus software, I have to manage it, right? So every now and then it gives me prompt that it has to either upgrade it, or it somehow it gets if the machine gets corrupted or something, I have to reinstall my antivirus software. So those kind of things, right? Services in IT, it's very simple. So like if I have to build a website for myself, I go ahead and I ask couple of good technical folks, this is my requirement, get me a website build please, right? So I get it as a service, right? So this basic concept of service is something which has revolutionized the IT, and it is the base for the many features of cloud. So that's what is the main point which I'm trying to make over here. Okay. So having said that, let's go into and try to look at the traditional approach of running software applications in organizations. So that's what we will look next. Okay. So traditionally, this is how it has been happening. So I have an office, and then I have a data center where I as in the IT department of an organization. Okay. So I have purchased different physical servers from different vendors. I bring all those servers, keep them in a nice building which I can call as a data center. I network them together, plug them together, install the required operating systems or different softwares which are required, right? I manage them. When I say manage them, there are all kind of maintenance which happens when these servers are there inside a data center. It generates huge amount of heat, right? So a lot of cooling equipment is also required, right? And then I have to manage and maintain the electricity which is required. Not only that, I may also have to get into people, because it's a data center, it's a separate building. So there would be people who would be taking care of the facility, the security staff, and all those things, right? So as an organization, I have to invest in such a setup, and then I have to run such a setup, right? So I'm purchasing not only the hardware, also the software, and I'm running it and I'm managing them. So this has been the traditional approach from a very long time. Many organizations, many enterprises have been operating in such manner. Okay. Now Having set up the required base, conceptual base, and also discussed about the traditional way of doing things in terms of how the enterprises and organizations have been doing, let's try to just go through the problems which cloud is trying to solve and which cloud has identified in the traditional approach, right? So as we can very clearly see, right, there is a huge amount of cost which is involved over there to manage, maintain, and run the data center, right? So it's very different costs, right? It's people cost, it's the electricity which we are paying for, it's the supporting equipment, right, the cooling equipments and whatnot, and maintenance of them. So I'm not even talking about the maintenance of the physical servers, I'm talking about the maintenance of equipments which are required to run those servers, right? So there is a huge amount of cost involved in that, right? Data centers typically, usually enterprises, organizations, they don't build, they rent it out, right? So there is a rent for which the organizations have to pay for that data center as well, right? So pay for the power, cooling, maintenance, the data center costs, right? And then there is not only just about the cost, it's about time as well, right? So whenever you have to purchase any additional hardware, right, or you have to replace any hardware, it takes time. Why? Because in big organizations, you have to first create a budget, right? These are the things, or these are the servers which I have to procure or I have to replace. You have to give a business justification that these are the reasons for doing that, get the required approvals, right? After getting the required approvals, it goes to your procurement department. The department, good best case scenario, already has identified a vendor. If not, then the procurement department goes out and looks for different vendors, finds out what is the right cost, negotiates for the cost, places a purchase order, right? After placing a purchase order with the vendor either is, it typically, it doesn't happen that the vendor is going to or is manufacturing all the parts of that particular hardware, right? So that vendor also has got a supply chain, right? So it also gets its different parts from different suppliers or factories, right? Assembles them, and then there is logistic also involved, right? Physical transportation of these servers, right? It comes to your doorstep, right, to your data center, it gets unpacked, then you have to have your networking team take out them, assemble them, plug into your network, switch them on, right? And then do some basic maintenance, or there could be some requirement from your organization that you need to have these many security patches, or this kind of software is required, and then it is up and running. So you can only imagine how much time it's gonna take for adding and replacing hardware, right? And then that is why the next point which comes, the next problem with respect to scaling, right? It is, scaling is very difficult, right? So what I mean by scaling is, scalability is the ability to easily add or subtract compute or storage resources, right? So it's the IT resources, we can say. So ability to easily add or subtract IT resources is what's meant by scalability, right? So we can see scalability is definitely an issue over here, right? And the last point, definitely we need a team, right? So we need a team to monitor the infrastructure. And when I say infrastructure, such infrastructure has n number of different equipments, physical servers, cooling required, and whatnot, right? So after having discussed all these issues or problems in the traditional approach, right, the question comes, how can we make it more effective and more efficient, right? So that's what we are trying to move. Okay, with that background, let's try to go to another concept which would be a solution. With the concept is cloud computing. Okay, so we'll spend some time, we will make sure that each and every one of us understands this concept very clearly, and especially the words, the keywords which are there on bold, okay, in bold. So it says cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. Okay, So let's break it up, right? Because that's what we want to do in today's session. We are going to break up things and understand as much in detail as we can. So what is on demand, right? So there is a very high emphasis on this word on demand. So in your cloud journey, whenever you will be going through more and more literature, you will find this word very often used. So before going to what is on demand, let's try to understand what is not on demand, right? So in the previous example where I was talking about the different problems, so how we explained to you, right? So there was a need for an organization to obtain a new physical server, right? It's an IT resource, it's a physical server which the organization wanted, right? And I explained you the complete process. It's a typical process which most of the organizations have, right? So one can easily say that such a process is going to take at least, anywhere ranging from 1 to 3 months, right? So what it means is that if I am a business owner, right, I own an application, and my technical team has told me that, Ankit, we want a new physical server because of this is reason. So I have to give this demand at least 1 to 3 months in advance, right? So why what I tell to my technical team is, don't come to me on the last moment. If you would need a physical server or any IT resource, you have to tell me well in advance, because we don't deliver IT resources on demand, because there is definitely a lag over there. It takes a certain amount of time for us to go ahead, get all the approvals, procure, and get the thing up and running. So this is not on demand. I will repeat, this is not on demand. What on demand means is, I will ask for a thing when I need it. Okay, my throat is dried, I am thirsty, I will ask for a bottle of water right now. I am not going to forecast that I am going to get thirsty after 5 hours, and then 5 hours in advance let me have a bottle of water. It is not on demand. Okay, so again I'm repeating because it has to be emphasized and every one of us need to understand. On demand means I am getting what I need when I need it, and that's when I'm creating a demand. I immediately get it and I start using it. Okay, then the second phrase or the term which comes over there is over the internet, right? So what does over the internet mean? Okay, over the internet, what it means by is, whenever we are getting any IT resource. So for example, if I have a requirement that I need to have a physical server in which the need for me is, I want to run a database engine or database application inside a physical server. I have to build an application, right? So what I eventually do, when I get a physical server, I go to that server, I switch it on, right? Physically, I'm doing it. I get a login console, I log into it, then I start installing the application, the database engine which I want to install in it, right? How can I do that? Either I have a compact disk. I mean, traditionally that has been happening. So you get a compact disk, you have a product key, and then using the compact disk you install it, or you connect to the internet, download the relevant files, and install the database inside it, right? So all these things you typically do. You are able to see your physical server. You are actually able to touch it, feel it, and physically switch it on, insert the compact disk, and everything you are doing. Over the internet means is, you don't know where your physical server is, right? Definitely, even if it is cloud computing, there is physical server involved, where a lot of virtualization, everything is happening, which we will cover in later slides. But you don't get to see the physical server over there. When you have to connect, you connect it over the internet. When I say connect, you have to get into the server, right? You have to do certain things, you have to install certain applications, packages, and all those things, right? So you connect to the server over the internet, and then you start doing your things. So that is what is meant by over the internet, right? And the last phrase, which is very important, is pay as you go pricing, right? So what it means by is, you have to pay for only thing, for whatever thing you are using, right? Okay, so and definitely in the whole discussion today I'll be giving a lot many examples for different services, and we'll be exploring together, like, how this pay as you go kind of a pricing apply to that kind of service, right? But what it means is that I will pay for only that much amount of time or that much amount of resource which I am utilizing. There is no point I pay upfront for the complete thing. Okay, so that is what is meant by pay as you go pricing. This is something which we'll be exploring in different modules. Second point, which is very important, provision exactly the right size and type, right? Again, it's a very important thing to understand and appreciate. uh, exactly the right size and type is that, again, going back to the same example, right? So there is a lead time of 1 to 3 months, right? It could be even more in some organization. I'm just taking a best case, right? So after 3 months, my server is going to come and sit in my data center in which I can do certain things. In 3 months, what happens is I, as the business owner of the application, find out that the demand which I had forecasted is something which is not correct right now. 3 months have passed and my physical server is on my doorstep, but I'm seeing that the demand is even more. So the physical server which I had ordered, let's say it was of 16 GB RAM, okay, let's say 8 virtual CPUs, that kind of a configuration. Okay, I had ordered, let's say, some version of, let's say, Windows Server 2000. I'm just taking an example, right? So this is the configuration which I had ordered, and I see that the size which I had ordered, the configuration which I had ordered, it's no longer relevant because 3 months have passed, and I'm sensing a lot of things have changed. The demand is now even more. So what should I do with this, right? When we say type, right? So in 3 months, there was a new feature which the development team has developed, which kind of requires a different kind of version of the operating system, right? So type of computing resources, right? So the type could be the the type of operating system which you are opting for, right? So in a nutshell, because of the traditional way of doing things, we had this issue. But with cloud computing, this is not an issue anymore. We can provision the exact right size and the type of computing resources which we want in an on-demand way. Okay, all resources can be accessed instantly. Exactly, because when we are talking about cloud, there are many aspects with respect to networking, storage, and all other different surrounding things which cloud manages for us, right? So all these, because of all these surrounding capabilities which cloud is managing on behalf of us, we can access these resources, we can make them productive very easily, instantly. Okay, so this is what is cloud computing. It's a concept which we have understood, right? Now in this specific slide, we have spoken about IT resources, we have spoken about the delivery of IT resources over the internet, right? So let's take a look which IT resources we are talking about, okay, on this specific slide. Okay, so broadly we can definitely there are much more categories than the ones which you are able to see on the screen. Okay, so what people have been doing is, depending on the resources which are getting delivered via cloud, we are categorizing them into different kind of services, right? Software as a service, platform as a service, infrastructure as a service, and every another day, every another year, we get to hear a new term, right? Serverless we are hearing about, right? And so many things. But these three things, I think, are one of the foundation things which are required for us to understand. Okay, so very first thing is infrastructure as a service, right? So when we talk about infrastructure, right, what we mean by it, right? When we talk about infrastructure, we mean by is the actual server, the network layer which we were discussing, the operating system, any storage which is required, to install an application, right? So that is storage, any virtualization technology, right? So this is what the infrastructure layer covers, right? So when we say infrastructure as service, so these are the two great examples of these two companies, Rackspace and DigitalOcean. So these are offering this capability, this bunch of IT resources as a service, right? So again, we will connect back to what a service means by, right? It's a service which we can use, we can pay for whatever we are using, right? And then we are not required to bother about physically maintaining or managing them. So I am, as a consumer of these services, of this servers network layer, right, the storage layer, so I am not required to worry about managing or maintaining them, or worrying about whether there is sufficient cooling equipment there or not, right? Whether there are sufficient people taking care of it, right? The cost required involved in it, the extra effort required to manage all these things. So I'm not required to worry about any of these things, right? I get my server, I can then do whatever I want to with that server. I can install an application, the database engine, or whatever I want to. I can build up my applications, deploy applications. I can do all those things without worrying about those aspects. So this is the very first layer. When I say layer, what I mean is infrastructure is the most, it's the bottom piece of the complete hierarchy, right? So that's what that's why I'm trying to refer it as a layer, right? So this is the infrastructure as service. If we go slightly up, all right, so when I say go slightly up, I am just referring to the stack as, like, we have the infrastructure where we have server, then we have operating system, then on the operating system we can install our applications, right? So it's a stack which we have. So that is what I am trying to refer as a layer. So when we go beyond that, when we just come towards more of towards the operating system or the applications layer, here comes the platform as a service, right? So again, two great examples, Google App Engine and Heroku. So what they do, they not only are doing infrastructure as service, but they are doing something additional as well, right? So they are giving us not only the infrastructure, but a surrounding suite of some applications running on that infrastructure, which can help us create our application, right? So for example, Google App Engine, right? So it comes up with nice set of different libraries, different engines in which I can create my final application without worrying about the surrounding capabilities, right? So that's what is meant by platform as a service. Finally, we come to the topmost layer, which is software as a service. It's a very common thing. We all in some shape and form have been using it. For example, Gmail, right? So it's a email as a service, right? So we are not bothered about which are the physical servers on which email service is running, right? We are not bothered about how this email application is created, what are the surrounding capabilities required to run an email application, right? We are not required to bother about it. We just log on to, we just go to internet, open our browser and start using Gmail, right? It's an email as a service which we all use. Similarly, Dropbox, again, everybody, I mean, most of us must be aware about it. It's we can use it to store our files, videos, PDFs, and whatnot without ever bothering about what is happening behind the scenes, right? And the key thing, again, we will connect back to the definitions which we have been learning. Again, the key thing is it's on demand, right? So I have to store a file, I just open my browser, log into my Dropbox account, store it, right? It's pay as you go pricing, right? How much you want to use, there are different. So for example, if you talk about Google, there are different brackets. If you want to, you can purchase that bracket, right? And then you can bracket as in the amount of size, the amount of space you want to block for yourself, right? So all these different type of companies, whichever services they are offering, they have their own pricing strategies in which you can choose the right size which is okay for you, right? And then accordingly you can pay for, right? So these are the different flavors, okay, of different services which companies have been offering, right? Now After this, we will try to also look at from a deployment perspective, because we looked at we looked at the traditional deployment, right? And now let's try to look at the three different flavors which cloud gives us for deploying the applications, and then how can we leverage them. Okay, so the three different flavors, or the three different ways in which we can use cloud, right? We can deploy our applications are public cloud, private cloud, and hybrid cloud, right? So these are the three different ways or three different strategies depending on your use cases, and there are many things which one will have to consider when an organization or an entity has to choose which model they want to go for, right? The deployment model, how they want to architect their applications, which application should reside where, right? So that kind of a decision, these are the three options which we can have, right? So when it comes to public cloud, uh, we have examples. We have Google Cloud, we have Azure, we have Amazon Web Services, which we are studying today, right? So in public cloud, the resources, right, the different IT resources, they are owned and operated by a third party, right? So third party means I am a company, and whatever is outside of me as a legal entity, that I can say is third party, right? It's a separate legal entity, right? So it is owned and operated by a third party company, which is not part of my legally. Okay. And of course, over the internet, again, we know what does over the internet mean, right? It runs all the parts of an application in the cloud. So what it means is, as an organization, what all applications I have, right? So I can have different types of application. I can have some in-house applications which my internal employees are using, right? My in-house portals, my leave management systems, my performance management systems, my learning applications and whatnot, right? I can have some applications which my customers are using, right? So all the applications which I have, I I'm using cloud to host them and run those applications. So this is one important aspect of when I say my applications are deployed on a public cloud. So I'm running all parts of my application inside a cloud. It could be any of these clouds, right? Definitely, there is a point with pointer with respect to migration as well. So if I am adopting public cloud, let's say I am an organization, I have been into operation 10 years, I have my own data center, I have my n number of applications, and when I choose to go on public cloud, I mean there is a need of migration, right? So I may need to migrate my existing cloud applications inside the cloud, right? And then definitely there is a specific module also which we will be talking about, which will cover how you design and what are the strategies when you have to migrate. Okay, so this is what is meant by a public cloud. This is one approach or strategy one organization can have, right? Second, it comes to private cloud, right? So when we talk about public cloud, definitely there is a lot of sharing which is happening, right? Sharing, right? So sharing of resources is the concept or is the main theme, how cloud is able to give a lot of value to all its customers, right? So when I say sharing, it's the sharing of physical resources, right? So there is a physical server, actual physical server, which will be shared, right? So how it is shared, there is a lot of virtualization technologies and whatnot, so through which we create different virtual machines and all those things through which we share the resources, right? So when I am on the cloud, a lot of sharing is already happening behind the scenes, right? There could be some situations, right? There could be some sensitive applications, some confidential data, some banking or financial applications where the governments or the regulators are not allowing that the applications or the data should be hosted on a public cloud. It happens, right? So for example, in India, if I have to give an example of in India, here the Reserve Bank of India, which is RBI, is the regulator for all our banking and financial applications, right? So it has a clear mandate that the banking data, like the transactional data and everything for a bank, cannot be on a public cloud. Okay, it's a mandate from them, right? So that's why, I mean, there is sensitive applications, right? It's a specific business needs. So because of that, what happens is, I as an organization cannot deploy my applications on cloud. Why I want to do that? Because definitely I have already understood that there are a lot of benefits of cloud, right? Which I've already seen. But because of these issues, not issues, because of these constraints, I am unable to do that. So the option which I can choose is to go for a private cloud. In private cloud, the IT resources are not shared. They are used by a single organization, right? So that's the main difference and the reason why private clouds are in existence. For example, Rackspace. Okay, so in Rackspace, I can procure specific servers, which are actual dedicated servers, which are dedicated to my usage. But I still get the benefits. What benefits? For example, I am not required to manage that server, right? So manage that server from operations perspective, from all other things which we spoke about in our last slides, right? So that advantages I can still get by using private cloud. Lastly, we have a hybrid cloud. Okay, so as the name suggests it's a hybrid approach, right? So, and you would find that many organizations use this approach where they, because why this approach? Because many times it happens that the nature of your applications is very different. There are some category of applications which can be hosted on a cloud, whereas there are certain applications, sensitive applications, confidential data or something, which cannot be, right? So you have a mixed and match kind of an approach where you deploy certain applications in a private cloud. Okay, and then you deploy certain applications on a public cloud, right? Here you can also say a different version of hybrid cloud could be that instead of even a private cloud, what I can also choose is I can deploy certain applications on premise also, right? So that on premise could even mean that I have my own data center. In my own data center, I have deployed certain applications, and then I have certain applications which I have identified, which I'll be putting out on a cloud, right? So this is also an hybrid model. Okay, so definitely I am able to get benefited because of the flexibility and the cost effectiveness of a public cloud, while I am able to control the sensitive nature of certain applications as well, right? So this is hybrid cloud, right? So we are progressing towards the end of our first module. Uh, we we have gone through different concepts. We have learned about cloud computing. We have learned about different flavors of services. We have learned about different deployment models. So let's quickly summarize the 6 benefits, the advantages of cloud computing. I will not be explaining them in detail because we've already touched upon them in great length in this module, right? So first one is trade upfront expenses for variable expenses, right? So upfront expenses, right? For example, I have to invest in purchasing cooling equipment, right? So it's an upfront expense for me, right? So I'm not required to do that, right? It could be I am replacing my upfront expense, right? Capital expenditure, the upfront capital expenditure, I'm replacing it with a variable expenditure. Of course, even if I'm on a cloud, there is a cost to be paid, right? But it's a variable. Why it is variable? Because it depends on how much I am using it. So this is the very first advantage, that I am able to replace or trade upfront expenses with variable expenses. Second point, which is important, I think we did not explore this in this module earlier, so I will spend some time on this. Benefit from massive economies of scale. Again, it's a very important point, and this concept of economies of scale, right? So I will just take a few moments and explain this concept in a very basic way. So for example, if you are trying to bargain, you go to a market and you try to purchase any product or service, right? And when we often use this tactic that, let's say if we are trying to make a bigger order, right? So many products at bulk we are purchasing, right? So we often tell the producer or the manufacturer that you should be able to give me a good discount, right? We often do that. Every one of us do that, right? Why? Because we are utilizing this underlying concept of the principle of economy of scale, which means is that when we manufacture, or if we do something at scale meaning at higher numbers, right, then the cost of doing that thing, right, the manufacturing something or whatever thing we are doing should go down. I am not using the word must, I am using the word should, right? Because economies of scale also, they kind of plateau, or they kind of don't fall down much after a point, right? So that is why I'm very carefully choosing this word should. So I will repeat, uh, when we manufacture or do something at scale, then the cost of doing that thing should go down, right? So for example, in India we are using big basket, right? So big basket truck, let's say it has a capacity of 50 boxes, right? And today, I have received an order for which only 5 boxes will be sent, right? So I'm not utilizing the remaining 45 positions, or the places on which I can keep the boxes, right? But the delivery guy who is owning that truck is going to charge me the exact same amount, right? But if I'm able to get so many orders, if I'm able to manufacture at scale, if I'm able to deliver 50 boxes, right, so then my cost as a manufacturer, as big basket, comes down, which I can in return give this benefit to my end customers, right? So same concept applies to cloud as well, right? Why there are economies of scale? Because there are so many customers who are ready to utilize the shared resources. Here also there is a sharing happening, right? So the example which I gave big basket delivery truck, in which I have got 50 boxes which are getting delivered, right? So one box belongs to me, one box belongs to somebody else, but there is a sharing of the delivery truck. It would be very stupid if there is a individual truck getting delivering individual items for individual families. It would be very stupid, and it won't make any business sense, right? So similarly, when you talk about cloud, it has a lot of physical servers, and then there is sharing happening at different levels, so that we can achieve economies of scale, and then the customers are benefited because of these economies of scale, right? So this is the second point. Stop guessing capacity. Exactly, we are not required to stop guess capacity. Why? Because cloud delivers on demand. So whenever I'm having the demand, I know what is the demand, I can quickly get those IT resources delivered to me, and I can access them over the internet. Okay. Increase speed and agility. Of course, I mean, I'm very agile, I can quickly respond to different changing situations in my business, right? Stop spending money running and maintaining data centers. Of course, we have spent good amount of time on this. Go global in minutes, right? So this is one again advantage. When we will be doing a module of with respect to infrastructure, where we will see the different regions, and AWS is global, right? So it has data centers. AWS, it has data centers all over the world. So today I am, let's say I have this big basket, right? So I am operating in India. Tomorrow I want to go global, I want to launch the same service in Japan, right? So we have AWS has data centers in Japan, in that area, right? So I can go global in minutes, just like that, right? So that's what it's meant by go global in minutes. So these are the 6 advantages of cloud computing. So I think with that we have reached the end of our module 1. We will take a very 1 or 2 minute short pause to be able to answer if anyone has any questions. Priyadarshan, if you are able to say any questions, if you want to respond to our chat, I'll just a 1 minute pause.
Thank you, Ankit. Yeah, I'm trying to reply to everyone's question. If not,
Okay.
yeah, there are a lot of questions coming in, so I'm just trying to as much as possible. There are some people as having difficulty in joining, also I'm supporting them as well. So yeah.
Okay. 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 So should I continue if you don't have a heavy backlog of responding?
Yeah, as I said, just pause for a minute. We'll
Okay.
continue.
Sure thing. Sure thing. Sure thing.
Ankit, there is a question for horizontal scaling. Could you please answer it quickly?
Okay, so as in just explaining the concept again.
Yes.
Okay. Sure. So, very quickly, we'll touch again. Okay, so let's try to understand vertical scaling first, and then that will make it easier to understand the horizontal scaling. Okay, so vertical scaling means is you are giving extra muscle to your existing machine, right? So, for example, you have a machine which has like 4 cores of CPU and 2 GBs of RAM, right? So, if I have to give more muscle, I can increase the CPU, or I can increase the RAM, or I can increase both the things. But what essentially or in principle I'm trying to do is I'm trying to meet the increased demand by increasing the configuration of my existing machine. So that is what is meant by vertical. Now when we look at horizontal, what it means is that instead of just increasing the configuration of existing machine, I increase the count of those machines, right? So I increase, let's say I put one more laptop or one more server, right? So for example, I have a website, right? And that website is being served from one web server which is residing on one physical server, right? And I start seeing a lot of demand happening. So what I can do is, instead of choosing to increase the configuration of that one server, right, I can put one more web server in parallel, and then I can put a load balancer on top of that, because there has to be some entity which can serve the traffic from each of any one of these servers, right? And then I can meet the extra demand. So this way, when we are trying to scale in this fashion or this strategy, we can call it as horizontal scaling, right? So horizontally we are trying to add more items, servers, right? And then we are trying to scale. I hope that this was able to clarify horizontal scaling.
Thank you, Ankit. So we can maybe continue with the module 2.
Okay, thank you. Okay, so in this module, this is going to be the biggest module. I hope everyone joined the class either after doing the dinner or doing lunch. Done your breakfast, or we have folks from joining from Australia. They have done their lunch, because there's going to be a bigger module slightly. So I will not be going through all these things right now on this slide, but if you will see 2-3 keywords over here. We are talking about EC2, we are talking about load balancing, we are talking about auto scaling, we are talking about SQS, we are talking about SNS, different compute options. So we will go and understand all these things in much more detail in this module. Okay. Before we go this, I will just try to revise what we have learned, right, very quickly. What In traditional way, if we were doing, we were spending money upfront to purchase hardware, we were waiting for the servers to be delivered to you, we were installing servers in our physical data center, we were making all these configurations, right? So these were the things which we can categorize as traditional way. And with AWS or with the cloud coming in, we have seen what are the 6 advantages which cloud gives. All right, so I've just revisited these issues, and we have also already gone through the 6 benefits, right? So now it's important that all these services which were listed on the last slide, how these services actually help achieve these things. We have spoken about different issues, we have spoken about advantages, right? So how these things actually go ahead and help us do that, right? So the very first service for today which we are going to learn and understand is EC2. Okay, so EC2 stands for Elastic Compute Cloud. C is coming twice, and that's why it's EC2. Okay, so what is an EC2 service, right? EC2 service provides secure, resizable compute capacity in the cloud as Amazon EC2 instances, right? In a very simple words, it's a server which we can get access to instantly and on an on-demand basis, right? So we will definitely be doing a lab also, but that's what it means by it, right? So it's secure, right? It's resizable. What it means is definitely when we were looking at the issues, 2 issues which we saw: adding, or rather getting a new thing, or resizing an existing thing. So that's what it says, resizable compute capacity. When it says compute capacity, what it means is compute capacity is the CPU power. So we can resize it, right? I can change, or I can increase or decrease the number of CPUs available to me. I can increase or decrease the RAM available to me very easily. So I can modify all these things very easily, right? And it's I can do all of these things in a very secure way inside cloud, right? So we can provision and launch EC2 servers, right, within minutes. Okay. We can, there is a life cycle also. When I say life cycle, what I mean is we start a server, we can stop it, right? And then we can also terminate it, right? So what I mean by terminate is, just letting it go. We don't not we don't need it, right? uh, of course, we have been talking about at great length, pay as you go. So that's what it is. You have to pay for only the time your instance, what I means by instance is the server, right? The EC2 instance. So that is how AWS denotes a server, AWS EC2 instance. So that's what it's saying. When an instance is running, right? So that is the time for which you have to pay. So in 24 hours, if I have my EC2 instance, which is nothing but a server, running for 1 hour, then I am required to pay AWS only 1 hour. For rest 23 hours, I can switch it off. I can stop it. And then when it is stopped, I am not required to pay, right? So this is wonderful, right? If you have to procure a server, keep it in your data center, it doesn't matter. It's your server. You have already paid the cost for it, right? You have already purchased it. It's up and running, right? And this is the exciting part of pay as you go model, right? Lastly, definitely, I mean, there are different capacities available. When I say capacity, what I simply mean is the type of RAM it has, the type of CPU it is using, right? The type of storage, the type and amount of storage it is using. So according to these things, you AWS decides how much amount you need to pay, right? So that's also wonderful, right? So we'll quickly see, how an Amazon EC2 works. I would request each and every one of you, if you have already created a AWS account, then it is time for us to log into that AWS account and see this actually running and happening. Okay, so I will be doing it on my local machine, which I'll be sharing, and then you can follow along. Okay, so I'll just take 15 seconds pause for you to open your browsers and log into your AWS account. So we are doing a lab. The objective of the lab is we need to actually see what is an EC2 instance, how does it look like, and definitely it's a server, so how do I get connected to it? Okay, so let me start doing this. So for this training purpose, I have already created an account and a user for myself, right? So there would be many things which still will not be clear to you, right? So just ignore those for a moment. We will just focus on what we want to understand, right? Priyadarshan, my screen is visible, right? On which I will be doing the lab.
Yes, sir. Yeah,
Okay.
it's visible.
Okay, thank you. So I am logging in. Okay, it is giving me an error, so I need to use the right password. Okay, so I have logged in. What I need to do is, this is the home dashboard. Whenever we log in, this is what it shows us, AWS Management Console. Okay, so on top you can see a search bar over there, right? So there we can search different services, right? So here we need to search for is EC2. Okay, so I have logged in. After logging in, even if you're not seeing this screen, but you will see this search bar on top. You can search for EC2. You can click on EC2. Okay, so now you will be taken to the landing page for it is the EC2 dashboard. Okay, so the dashboard for EC2 services, right? And when we talk about EC2 services, there are definitely lot many surrounding services around EC2, right? So let's let those things not distract you. We will simply go and launch. Okay, so after coming over here, you can click on this instances running, or you can do a launch instance. So what I will do, I will be launching a new instance. So launch an instance. Again, Amazon EC2 instance is nothing but a server, right? So now you will be able to appreciate and understand the phrase over the internet, right? So see what is happening, right? So right now, when I clicked on launch an instance, what I'm trying to say is, hey AWS, I want to launch a new server for myself, right? So it said, okay, which kind of server you want to launch, right? It could be Amazon Linux server, it could be Ubuntu server, it could be Microsoft Windows server. What kind of server you want to launch? There are many different varieties which are available, which I can choose from, right? In AWS terminology, AWS calls these as AMIs, okay, Amazon Machine Images, right? So these are the different images, right? So if somebody is coming from virtualization background, it's an image, right? So it contains all the necessary files, relevant data, which can help us launch that specific operating system, right? So that's an image, right? So we can select from different images which are available to us. So right now I'll be selecting Amazon Linux 2. Okay, it's a Linux base. It's an Amazon flavor for Linux operating system. So I select that. Okay, definitely there are different instance types. We will be talking about them. Okay, but I will be just skipping it for now. Okay, again we'll be spending some time on this in later slides. So I'm just skipping. We'll definitely explore them. What are these? But for now, I'll be skipping them. Okay, so there were certain things which AWS or the the launch wizard, right? So it's a easy to launch wizard. Wizard is like a series of steps to do some things, right? So it's a 7-step process, right? So there were 7 steps. There were certain information which AWS asked me, right? So I've just spoken about one thing, which is this image, right? Other things we will explore. So I've done all these things. I just click on launch. Okay, so right now it asks for me a key pair, right? So definitely it's again secure, right? So it creates a private key for myself. I had already created a private key for myself, right? So private key is nothing. You can simply understand it like it's kind of a key which I have to use when I have to log into my server, right? So I already had created a key. It is saying, do you want to use that? The name of the key was web app. So I say yes, I want to use that key. Okay, and I click on launch instances. So it says, okay, your instances are launching. I click on view instances. So when I click on view instances, it takes me to this dashboard. Okay, it's a grid which shows me what all instances are running, right? So this instance you can ignore. Okay, this is the one which we are launching. Okay, so as you can see, there is an instance ID. It's a unique ID which AWS generates. It's which says that instance ID, right? And state is running. So we launched an instance for ourselves. It's a server which we have launched, and it is now up and running. Okay, let me try to just connect to it also. Then we'll be done with this lab. Okay, so I select this. Okay, and then if I can click on connect, right? So definitely there are different ways of how can I connect with it. So I will choose this EC2 connect way, and then I will click on connect. So in a browser window, I'll be connected. Okay, so I can type all my commands, right? So people who have some background or are exposure to Linux based machines, right? So they can understand it's a terminal which has been opened for me, right? And I can do whatever I want to, right? And you saw, right, as we were talking about, in minutes I have launched a new server for myself, right? And there were definitely a lot of configurations which just in a minute we'll be talking about, and it's all there. I don't know what is the physical server, where is the physical server, whether there is a sufficient cooling or not, nothing. I had a demand, I just launched it, and now I can do whatever I want to with this server, right? So this specific server which I have launched, I can install my database engine or any web server I can install, or I can do whatever I want to. Okay, sounds good. Okay, so now I will be closing this session, the terminal session which I had opened for myself for my server. Okay, now we'll talk about all the different aspects, while we were launching it, what all things were important and what all of these things mean. So the very first thing which is important is the instance types. Okay, so what I will do, I will again click on launch an instance. I will not be launching, I'll just have that specific page being displayed. So this was choose an instance type. Okay, so let's go back to our main slide. So this is what we did in this lab. Now let's start looking at the different instance types. So what is an instance type, right? So that's the very first point which we want to understand, right? So we saw like server is nothing but it's a collection of different IT resources like CPU, there is RAM, and there is storage, network, and definitely lot many things. But for us to understand, these are the three main things which are there, right? So, and depending on different use cases, right, different workloads means how much, what kind of processing you want to do, right, what kind of applications you want to do. So you may choose different types of combinations of these things, right? I gave you an example of the issue which I was facing when I was trying to play this PUBG game. So that configuration was not suitable for me, right? So I had to change it, right? So similarly, if you are doing any high-end graphics, for example, Adobe or something, right? So you may want to choose a very specific configuration for your specific application or use case, right? So what AWS has done is it has created different categories. Okay, you can see on the screen there are around 5 categories. So they have created different categories, and each category is for a specific purpose, right? And depending on what you want to achieve, you can choose a instance, you can choose a server from that particular category. Okay, right? So if you will go here, right, so if you see this complete grid which challenges or which asks us choose an instance type, right? So it says that it provides a wide selection of instance type optimized to fit for different use cases, right? So that's what it has done. So you can see the type mentioned over here. Of course it is, it's mentioned as like T2 and different things, but so it's an acronym kind of a thing which AWS is using, because it won't fit if they start using all these words. So it's a short form of these categories. Okay, so this is what it is. So we can choose whatever we want to from here, right? For your purposes, sorry, I forgot to mention that while if you were launching a EC2 instance, definitely you should be, or you should have chosen free tier eligible, right? So whatever labs we are doing today, definitely if you are trying to launch, or after this session you are trying to launch, you can choose this one. Okay, so if you choose this one, you can see for 1 month, like 750 hours for this particular type, right, are free for 1 month. Okay, so that you can do. And of course if you choose two, then you are out of your free tier. So you can run only one server 1 month. So that's how you will be inside the free tier, right? So again, so this is a type, right? So again, we were talking about different types. So you can see, even if you don't remember, right, so there is no need to deeply remember what are the different instance types are available, right? It's just more from a guidance perspective. So even if you don't recall, while you're launching, you can see what is the configuration. As you can see, if you're launching a T2 micro, it's like one virtual CPU, the RAM is 1 gigabytes, right? And it also giving some indication like how the network is going to behave, right? So it's low to moderate performance, right? If you look at T3 nano, it says up to 5 gigabit the network performance, right? So uh, this is a great, and you can just explore. But definitely before launching an instance, you need to know what is your use case, what is the requirement you have, and then you can optimally choose from here, right? So again, we will go through and understand what is the concept, how AWS has uh, created these categories, right? So if you look at the general purpose instances, okay, so these instances kind of provide a balance between the compute, which is your CPU, memory, and networking. So it's kind of a balanced kind of a thing which AWS has created this category for. It can be used for a variety of uh, applications, or rather workloads. For example, application servers or small and medium databases, right? Small medium enterprise applications. So those things you can run. So again, this is a general guidance, right? So you can start from here, but definitely if you have to be very selective, then you need to know exactly how much amount of RAM you need, how much amount of CPU you need. So then you become very specific, right? But if you don't have those information, that those set of information with you, then you can go with this general guidance, right? So typical example of general purpose instances is over here. Again, especially from an exam perspective, you need not to remember like a typical example of a general purpose. Just for reference, we have put like for example, Intel Core i7 processors. Okay, so these are the typical memories of these servers, right? So this is what eventually, if you choose a server from this category, this kind of a configuration you can get, right? Again, I'm repeating, no need to remember exact details. It's just for this giving you an example perspective. Okay, second is compute optimized. As you would see, it is saying compute, which refers to CPU, right? So again, that's what it's also saying. It is ideal for applications that benefit from high performance processors. So if your use cases like you need to have high performance processors, compute sensitive applications, servers, dedicated gamings, and all those things, right? You're doing a lot of batch processing in which you have to fire a lot of instructions, right? So many transactions maybe you are processing in a group. So those kind of use cases, those kind of functionalities, if you are seeing, then you can come to this category and choose an appropriate instance, right? Okay, so again, for reference, there is one example, AWS Graviton 2 processor. Again, it's a AWS processor, Graviton 2, which comes as an example when you choose an instance from this category. Okay, then we go to memory optimized. Again, it's quite clear. It talks about memory, right? So memory as in especially the RAM, which is associated, right? So a lot of huge workloads wherein you have to do a lot of churning, you have to do a lot of processing inside memory, right? So those kind of things, if you have to do large data sets in memory, so this could be one category for you to pick and choose from, right? So again, one example is loaded on the screen. No need to remember, just for reference. Okay. Then we have accelerated computing instances, right? So again, I mean, many of us might have played different games, right? So typically, when we are playing games, there is a enhanced need of having a graphics card on the motherboard, right? So you need a accelerator for enhancing some specific functions, right? So we use hardware accelerators or coprocessors, so that some specific functions can perform more efficiently, right? So for example, when you talk about graphics card, it's the rendering, right? It's the fast rendering which is happening on the screen, right? So those kind of things, if you're doing any, for example, any data pattern matching, right, or those kind of things, so you can go for accelerated computing instances, right? So again, they've created a specific, as you can see, it's a NVIDIA A100 Tensor Core GPUs, which these instances are loaded with, right? Then we have storage optimized, right? So again, when it comes to storage optimized, we have huge databases, right? So we have an application, we have a lot of customers, and a lot of data has to be stored on databases, right? So here what is required is we need very fast read and write happening to our hard disks, right? So that is the scenario. Then these are the categories, right? Suitable. There could be different types of workloads, like you have data warehousing applications, right? Or you have a scenario where you have to do very sequential read and write from large data sets, right, on a local storage, right? So in those scenarios, you can pick up an instance from this category. Okay, so these are the instance types, right? So this was that screen which on the EC2 instance launch wizard, which kind of gives us these different options to choose from, right? So again, I'm just repeating, these categories are more from a guidance perspective, right? Yeah, but you can be very specific if you have a very specific need. Then what kind of a how much CPUs and memory you want, right? And also with specific instance type, there are certain aspects or elements attached to it, right? So for example, if you look at this grid, it only talks about the CPUs and memory, right? But we saw that there are certain categories which give more importance to hardware accelerators, right, or on storages, right? So there you have to pick up a specific type, right? So if I want those things, so I have to select a specific type, and from that type also I can pick and choose how much CPU or how much RAM I want to. Okay, so let's move ahead. I will just go back to the slides. Then we will be looking at the pricing aspects of EC2, right? So definitely we have seen that there is a pay as you go kind of a model, right? So that model is definitely there. So how much time your EC2 instance is up and running, only for that much time we need to pay. So here and also there are different options which AWS gives us. There are 3 different options to select with. I'll just explain the options, then it will become clear to you what I'm talking about. Okay, pricing options. So there are 3: on demand, spot, and reserved instances. Okay, so if I go directly to my launch instance wizard, okay, so here is a purchasing option. I can request from spot instances, right? If I am not requesting from spot instances, it is a on demand option, right? I will explain what are these options. Okay, I can also do reservation, right? I just mentioned reserved instances, right? So I'm just relating what are these options present on this specific screen. Now let us understand what these options are, like on demand, reserved, and spot. Okay, so on demand is the most commonly used kind of approach. So what it means is, you just want to launch a server, you obtain it, you use it for whatever time you want to, you stop it, and you're done with it, right? So what are the use cases where you want to do this, right? So for example, if you have short term or irregular workloads, right, that cannot be interrupted, right? So for example, my scenario is that I am doing I have to start my own company, right? So I need to create a web application for my customers, right? But since it's a startup, I don't know, like if I'll be in business after 6 months or 8 months or after a year or not. It depends how much my business grows, right? So that is what is meant by short term. Can I be interrupted? No. At least for 6 months I need these instances to be running because I need to serve my customers, right? So in such a scenario, the best option for me to choose is on demand instances, right? So on demand instances, of course there is no upfront cost. There is no contract, nothing, right? And then whatever I'm using, that much I have to pay, right? Now what AWS also done is how it created the second category, which is reserved instances, right? So for example, after 6 months or 8 months, I come and say, oh, my business has grown and I have a visibility. I can very easily I'll be able to be in business for next 3 years. So I'll be using the same web server, I will be using the same EC2 instance for at least 3 years, right? So if I have this much of clarity, can AWS do something about me? Can you reduce the cost? So that kind of discount or maybe negotiation I want to do. So that's where AWS has come up and they have created the next category, which is reserved instances. So in reserved instances, what happens is, definitely the use case has to be like either you are reserving for 1 year or a 3 year term. So what happens is, you pay some amount of fees or some amount of usage, how much you are be using, some amount of front, and then the cost of using the same thing for 3 years. Let's say it was, let's say, $1,000, right? If I was using one EC2 server for 1 year, if I go to AWS and say, okay, reserve this instance for me for 1 year, Okay, I'll be paying a small amount, let's say $50 upfront. Then after a year, instead of completely paying 1,000, it gets reduced a lot, right? So I receive a greater cost saving. Okay, so that is what is meant by reserved instances, right? So the bottom line is, or the catch is, that I need to have a clarity whether I'll be using this EC2 server for a specific, predetermined period of time or not, right? So 1 year or 3 years, right? And if I am able to, then of course I can get a discount. So that's the only thing. So that is why, AWS has created a category reserved instances. So while I'm launching, okay, I can choose from my reserved instances, right? So how to create a reservation is something which is entirely a different screen. So I have to go to a different service, different screen, and then from there I can obtain a reserved instance. So I can then choose a reserved instance while I am launching a EC2 instance. Okay, so in short, a reserved instance exactly behaves the same as on demand. Only thing is, I am telling AWS, hey, I'll be using it for at least 1 year or 3 year. Why don't you give me some discount? Okay, so that is what the conversation is all about. And then I pay some amount of front, kind of, locking in, because if I'm saying I'll be using it for a 1 year, if I don't use, what happens, right? So I pay some amount of front also, and then I'm locked in for that much period of time, right? And then I receive some cost saving. So that is reserved instance. Then the third category is spot instances, right? So it's a very different type of spot. I mean, different type of how, negotiations, or how you are able to save cost when we talk about spot instances, right? So what is the use case, when we can use spot instance, right? So first let's understand that. So for example, if I can withstand interruptions, right? So for example, I'm doing something, let's say, some pattern matching or something which keeps on happening and happening. Even if it is stopped for some time, it is okay, it is going to resume once it is started again, right? So that kind of a use case, or that kind of an application if I have, so what can I do is, I can go for spot instances. Spot instances, what happens is, I tell AWS, or tell that this is the amount which I am going to pay for this type of EC2 instance. It's kind of a bidding which happens, right? So let's say we are 100+ people, and for a specific type of instance we do a bidding, right? So whosoever bidding is the highest, that person gets the instance, and that person can start running the application, right? And then again the bidding happens after a specific period of time, and in the next bidding, if let's say I bid a higher amount, I get that instance. Okay, so it just these economics will change. Once I get an instance, then all the things remain same. It's an instance, it's a server, I can do whatever I want to with it, right? But again, it's an instance which comes fresh. I have to again copy my application and start my application, right? And there can be an interruption any point of time, right? Because when the next bidding is happening and somebody gives a higher price, then I lose that instance, right? So great cost savings happens almost 90% as compared to on demand, right? So these three are the different categories through which we can save cost, right? On demand, reserved, and spot. This has nothing to do with your instance type, I mean the configuration, right? And nothing to do with how you are interacting with your server, right? So you interact with your server, you do whatever things are required, so nothing changes. It's just that different options which AWS has given us, through which we can save our cost, right? Just when we're talking about cost, there is also one another way which AWS gives is EC2 savings plan, right? So here what happens is, instead of committing to a specific instance, what I can do is I can commit, right? I have to make a commitment, right? That's how uh, market or the economics work, right? I have to give a commitment for this much order, then I get a discount, right? So this is why this word is again and again committing, right? So when we saw reserved, I was giving a commitment for 1 year or 3 year to a specific type of instance, right? But then when we talk about AWS, there are other services also which use the similar compute power, right? When we will go to Lambda, Lambda is again a serverless service, right, which AWS is giving. So there also some compute is happening, right? How compute is happening? Because when we talk about Lambda, we have a function and we give that Lambda function which it has to execute, right? So whenever such thing is happening, there is an execution is happening, right? So when I say execution in technical terms, there is a CPU involved which has to process some instructions. Finally, this is what happens, right? So what happens in EC2 savings plan is we give a commitment for compute. So what I say is that these many hours of I'll be paying for this period of time for this much amount of computation. Okay, and if my I am within the range, like, so it's a reduced amount which I pay. I get benefit up to 72% of on demand. And if my computation crosses that much hours, right, so then for extra thing I have to pay for the standard rate. Okay, so for us to understand Amazon EC2 savings plan, what it is, it is again, it's a way, it's an option which AWS gives us to save our cost of running instances and compute. Okay, instead of, and how it is different from the three options, it is different because we are giving a commitment for compute. Okay, instead of giving commitment for an instance type, we are giving a commitment for compute. So this is the difference. Okay, finally the results are same. We are able to save costs for you by using Amazon EC2 savings plans. We can save up to 72% of the cost, right? Okay, so this is how we can save the cost thing. Okay, now on this, while we were launching it, another interesting thing which we need to know is the tenancy. Okay, shared or dedicated. So let's take a look at that. Okay, so shared versus dedicated hosts, right? Definitely the most common thing which most of the organizations do is shared hosts, right? So what it means is you have one server on which through virtualization many different virtual servers are running, right? So I can have a physical server on which my virtual server is running, and also it happens that your virtual server is also running on the same physical server, right? So this is how sharing is happening, right? AWS, there could be some situations or some use cases with some organizations where they say they no, I don't want any sharing to happen, I want dedicated hosts for myself, right? So AWS also offers that, and that is where I highlighted that this is an option which we can choose while we are launching an instance. And definitely, as you would be able to understand or predict, that the cost of doing that will be very, very high. If I tell AWS that I want to run a server on a dedicated host, the cost is very high. Okay, so this is the difference between dedicated host and server. Sorry, dedicated host and shared host. Okay, so this is what we have covered. There are some other things also which we will be covering while we are progressing slowly and we are trying to understand different aspects, right? So we will slowly be touching upon all these different options which we have to choose. But again, I'm touching for the exercise which we just did. You can leave everything as is and you will be able to successfully launch your EC2 instance. Okay. Okay, now we will be going forward and we will be learning two different very important services. Uh, those are auto scaling and load balancers. Okay, so but before we do that, we will just quickly take a look at a important concept. I think we spoke about it. I'm just revising it, which is scalability, right? So again, it's a concept alert. Scalability, what it means, right? So scalability involves beginning with only resources you need. Okay, and then you have your architecture in a way that whenever there is a high demand, you are easily able to scale out or in, right? So you can increase more servers either by horizontal scaling or vertical scaling, or you can decrease, right? So this is what is meant by scalability. So if I say my system is highly scalable, and while I was designing I paid a lot of attention to scalability, what I am trying to say is, if business changes, if the demand changes, if whether it is going up or down, I'll be able to meet that demand by increasing my capacity very easily, right? So that is what is meant by scaling. And after scaling, let's try to understand how to do scaling, right? So there are two ways of scaling, right? So for example, I am a system administrator. Business comes to me and say, oh, we have a big billion day, Flipkart big billion day coming in. There will be many people coming in, and purchasing. So increase your capacity. So I go ahead and add more servers, right? So manually I'm doing it, right? On the big billion day, what happens is definitely the load is fluctuating. Sometimes it is increasing or decreasing. If you are doing manually, if you are doing manual scaling, then definitely, if I have to be cautious, like whatever extra capacity I've added, if it is sufficient for that day or not. If it is not, then I will have to take some steps. That is point one. Even if we don't have such a big billion kind of a day, if you look at carefully at the slide, you will notice that in different situations, right, we have a very the difference between what is unused capacity and how is the demand. The difference varies depending on different days, right? It can vary. So for me, if I talk about purchasing anything from Amazon or somewhere, I mean, I am usually doing it on weekends, right? I usually don't get time on weekdays. So would be the case with all of you, right? So what this is highlighting is, even if we don't have such grand events as like big billion sale or something, even in normal day-to-day routine or operations, the difference between what is the demand and what is the capacity, right? The difference varies a lot. Sometimes the demand is exactly equal the capacity which we had, or sometimes the demand is very less as compared to the capacity, right? So that is why it is very important that we have some sort of mechanism, some sort of features available from cloud which can help us automatically scale. We should not be required to have one person or people sitting it and constantly monitoring and adjusting things, adjusting capacity, adjusting servers, removing servers all the time. It should be automatic, right? So that is the importance of auto scaling. So with that, we will jump into the service which is auto scaling. As we were talking about, Amazon EC2 auto scaling enables you to automatically add or remove Amazon EC2 instances in response to changing application demand, right? So these two words are very important: automatically add or remove with respect to changing application demand, right? So definitely, I mean, if you're able to do that, then we can add or we can remove, and we can be very agile with respect to how the demand is changing, and we can scale automatically. So that is the service which is automatic auto scaling of AWS, which we'll be exploring, right? In conjunction to this, in working hand in hand, we have another service from AWS which is elastic load balancing, which works very beautifully with auto scaling, right? So auto load balancing, many of you might be familiar with this. So load balancer, as its name says, it balances the load, right? So it acts as a front layer. Okay, so underneath we can have different servers which are serving some traffic. So let's say you have a web application, and then there is a web traffic which is being served by, let's say, 3 servers. So on top of those servers we have a load balancer, because your front end application is talking to the load balancer, and load balancer senses that out of these 3 servers, which server I need to send this request and get a response, and send this response back to the client, right? So this is what load balancers are. Definitely, when it comes to AWS offers load balancers as a managed service. What is meant by managed service is, if you have an on-prem application, we can have load balancers, right? We can have a load balancer software which we can ourselves install, manage, and run. But since we are on AWS, we are on cloud, so there are AWS load balancers which are like application load balancer or classic load balancer. These are the names, so we can use them. We need not to worry about what is the software running behind, what is the server, because ultimately load balancer is a piece of software, right? It is running on a server, right? So we need not to worry about, right, what is the software, how it is written, is it up to date, what server it is running. We do not worry about. We can simply create a load balancer, and we can have a couple of web servers running under a load balancer, and then we can serve the traffic. Okay, so with that understanding, we will simply go again a quick demonstration of the same thing. So for example, this is our design. So these are our two users. Okay, they are, let's say, Facebook users, and then when they request, the request comes to load balancer. Okay, then the load balancer is serving is forwarding those requests to these servers, which are EC2 instances. Okay, and then we have a group which encompasses these EC2 instances. We can call this as auto scaling group. Okay, I will repeat. We have two people, let's say Facebook users, who are when they are using Facebook application on their browser, that browser application is talking to a load balancer, and this load balancer is talking to either of these two servers, depending on which server has more load or less load. Okay, accordingly, this complete design is there. Also, we have an automatic scaling group, which is a group in which these two servers are included. Okay, now what happens is, suddenly there is a high demand happening. Instead of two people, there are four or more people who start using Facebook application. So what happens is, auto scaling group, right, and this senses that more load is getting created, so more demand is happening. So what it does is, it automatically scales, right? So we have still have a single elastic load balancer. Auto scaling group, what it does is, it senses that the previous only two servers were not able to meet the increased demand, so it adds two more servers under this load balancer. So what happens is, all the requests will come to this load balancer. This load balancer will sense, oh wow, I have got two more servers added, so I can pass the increased load, the increased requests, to not only these two servers, but I can distribute the increased load to now four servers, right? So this is how auto scaling work. Okay, so there are different rules through which auto scaling works, in which it can automatically sense that something is wrong or some demand is more, and it can auto scale. Okay, so it's a lap time for us. Priyadarshan, should do we want, since it's 11:27, do we want to take a pause, take a short break, or should I continue with the lab? Any
Yes, I was
thoughts?
thinking after the lab, but let's take a quick break right here, 10 minutes. Now we will start again. 11:35 or so. We can start again. So, yeah,
Okay,
please, everyone, please take a quick break here for 10 minutes. After that, we will start the lab and we will proceed with the other content.
okay,
Thank
okay.
you very
Thank
much.
you so much. Yeah, will it start at 11:35?
Yeah, we can start at 11:35 or 40. That's
Okay,
once we
11:40.
come back, with from the break, we'll start.
Okay, okay, okay. Okay, guys. So we'll start at 11:40, as Priyadarshana has said. I'll take a short break. You can also take a short break, and we'll again join back. Thank you.
Yeah, we will start at 11:40. Thank you, Ankit.
Okay, hello all. I hope everybody was able to take a short, quick break. I am audible and people are able to see my screen. Priyadarshan, you're able to hear me and see my screen?
Yes, Ankit.
Okay, thank you. Okay, so we will start. So before the break, we took a pause and now we will be doing a lab. So what we will be doing in this lab is we will be quickly checking three different services. Okay, so one is definitely we'll be talking about elastic load balancer. We'll be talking about auto scaling groups, launch configurations, and then we will be taking a look at how these things are working. Okay, so let's start with the very first thing. Okay. So on my screen, so this is the EC2 dashboard instances grid. Okay, so what happens is in my account, okay, so whatever servers I am running, I can get a very quick view of what all servers I am running. Okay, so right now there is one server which is running. Okay, if I click on it, I can see all the different details with respect to its IPs, how much storage is available, networking details, security details. So all those things I can check if I click on it. Okay, and then so this is part one. Now I will be talking about launch configuration. Okay, so what happens is when we talk about we understood the idea of auto scaling, right? So auto scaling is very in a very basic way. What it does is it observes a group of EC2 instances, okay, servers, and then it looks for some parameters, right? So those parameters could be, for example, one parameter could be CPU utilization. So I can say that I have two servers, and if the average CPU utilization across these two servers, if it reaches 90%, right? So that is how I'm telling auto scaling that is what that could be a point where huge demand is coming, right? So what I can tell auto scaling is observe these two EC2 servers and then create a rule, create a policy. To be specific, create a scaling policy where if you see that the CPU utilization, average CPU utilization for these two servers for a period of 5 minutes is more than 90%, then start a new EC2 server for me. Okay, so that's in a very plain and simple English, that's what I can achieve, right? Definitely there could be different parameters. Just one parameter I have given you is CPU utilization, right? Using which I can create some rules, right? There are different parameters. You can read about it, what all different parameters we can use, right? And definitely there are different ways of having auto scaling to observe our EC2 servers, right? But essentially this is what happens behind the scenes, right? Now when auto scaling is observing our servers and it senses that okay, something is changed, because I have told auto scaling that when my load is going or when the CPU utilization for these two servers is going above 90%, right? So you need to launch a new server, right? So definitely if it is able to sense this and now it is about to launch, right? So the very first question which auto scaling asks is, what should I launch? What kind of a server should I launch? Right, because we all saw that when we are launching a server manually, there are various parameters which have to be configured, right? Images, instance types, and whatnot. Many parameters are there, right? So auto scaling has to know what has to be launched, what configuration you want, right? So so to answer that, what we do is we first create a launch configuration. It's kind of a template. Okay, so I have created a launch configuration template for myself. Okay, so this is the template which I have created. If I click on it, so it contains the details, right? It contains an image, right? So this is the image which contains my operating system. It can contain surrounding third party applications as well. So for example, this server is something which runs a Apache web server on top of it, right? So my image has both the things. My image is a Linux machine image, and then on top of it I have installed uh, Apache web server, right? So this is the image. So I, in the launch configuration, I tell okay, this is my image, and then the other details, for example the instance type which it has to use, right? And other things, right? So we will be keeping exploring other things as well, like the security group we will explore, other things we'll explore, right? But essentially the concept of launch configuration is it gives the details to auto scaling. In using those details, auto scaling is going to launch a new server for me. Okay, so this is launch configuration. Now we come to auto scaling. Okay, so I'm just showing you before we do actual experiment. Okay, so this is a launch auto scaling group. Okay, so in auto scaling you can see this is the launch configuration where I mentioned the same launch configuration which I had mentioned over there. Okay, so that is one. After that we mention the automatic scaling policy. So in the scaling policy, I will not go in much detail, but at a conceptual level, that's what I'm trying to do. What I'm saying is, if the CPU utilization is more than 10, right? Because right now it is very difficult for me to just go do 100%. Okay, so it's not definitely a practical scenario, but it is good enough for us to demonstrate. So if the CPU utilization is more than 10 for more than 1 minute, then it is going to add one more server for us. That is a policy which I have created. It's kind of a rule which I have created, right? Okay, and if I go to instance, so this is the instance which it is monitoring, right? It's there is instance ID 6D50. Okay, if I go to instances, let me go to instances again. Yes, so it is monitoring 6D540. So this is the instance which it is monitoring for the rule which I have created. So whenever the rule breaches on this server, it is going to do something, right? So let's start the demonstration, right? So I have explained that this is the server. I have talked about there is a configuration involved, and then we have a auto scaling group as well. So what I will do for the first demonstration, I am going to kill this server. Okay, it can happen, right? We have all seen in production environment or something, instances get terminated, right? Maybe something happened, somebody has dropped water on it. Those funny instances can also happen, right? So the instances, the server is crashed. So that kind of a scenario I will create, and let's see what happens. So I will just select it. Okay, and then what I will do, I will go to, just a second, yes, so I will go to instance state, and then I am going to stop this. I can terminate also. I am just going to stop this instance. Okay, let me stop this. So it says successfully stopped. If I refresh this, it says stopping. So just be patient for a couple of seconds. It takes some time to stop, and then eventually the rule will get triggered and we will see a new instance coming up. So this is the one which we are doing an experiment with. Don't look at the above one. Okay, so this is the one which we are stopping, and this is the one on which auto scaling group is monitoring. Okay, yes, so you see a new instance is coming up with an ID 24E395. It says pending state, right? So it is shutting down, it is pending, and it is running now. So this is what we did, right? We terminated, okay, and then automatically a instance came up. Let's see what has happened to here. So on auto scaling group, we have a tab for activity. Okay, so if you look at activity, what just has happened? So right now in India it is around 11:48 a.m. So you can see at around 24th April 11:48 there was an EC2 instance terminated. Okay, it was terminated or stopped. Okay, so this is what signal it has received, right? Because it was monitoring that instance. Which one? 6D540. This is what we killed manually, right? And in corresponding to this, it has launched a new instance at 11:48 a.m. automatically. So it is recording all these activities, right? So this has happened automatically. It has launched an instance for us. So right now If I refresh again this grid, so I can see it is now running. There are some status checks which happen. AWS does, once the instance or the server comes up, it runs some checks on it, and when the checks are complete, we should be able to log into this. Okay, so this is part one. Second part, what we will do is we will try to check that rule which we have created, right? Where where the group is monitoring the CPU utilization, and we will increase the CPU utilization, and we'll see what happens. Okay, so that we will do. We'll just let it finish the checks. So this is our auto scaling group. It is still initializing. So what we'll do, we'll just quickly check some details over here. So here you can see desired capacity, minimum capacity, and maximum capacity. Again, it's a very important and interesting concept to understand. So just give me a second. I need to copy this URL. Okay. Okay. Yep. So meanwhile it is checking that, we will quickly check this concept. Okay. So yeah, let's ignore this for a minute. Okay. So we were talking about these three aspects: desired capacity, minimum capacity, and maximum capacity. So these are the numbers which we can configure while we are creating an auto scaling group. What it means is this, right? So what we can say is, hey, auto scaling, I want a minimum of, let's say, one server, which also always should be kept running. I desire that either it is minimum is 1 or 2. Okay, and then maximum I can go up to is 4. So if there is a need of scaling, you can add third and fourth. After adding 4, you should not go beyond that, right? So what we are telling auto scaling is, first we are giving a range by specifying minimum and maximum, and then we are telling it what is the preferred number which we want. So that is what it means. So when we are creating an auto scaling group, these are the three numbers which we have to give, and definitely desired has to be either equal to minimum or it can be equal to maximum. Otherwise it has to be in between these two parameters. Okay, so this is what is meant by these three specific numbers. Okay, so let us again check. It is good. So status checks have passed. So what I will do now is I am going to connect to this. Okay, so let me connect. Okay, so I'm connected to this. Let me first show you something else as well. Just a second. So what I will also do is I am going to so right now again what we are trying to experiment with is the CPU utilization rule which we have created, wherein if it is more than 10, it launches one more. Right now we have only one, which it launched as in reaction to our manual killing of the server, right? So let us go here. So what I'm trying to do is I'm trying to open a graph. Again, we are in reference service CloudWatch, which we'll talk about in later slides. But essentially, I'm going to open for ourselves a graph which is going to display the CPU utilization for our server. Okay, so let me open it for last 5 minutes. Okay, so from various different wonderful things, this is also one wonderful thing. we can have different graphs and everything for CPU utilizations and everything for the different EC2 servers or different AWS services, right? So that's what we are trying to use over here. Okay, so since there is a new thing which has got created, so let me see. Okay, so right now in my clock it is like around 11:55. It is showing value for 11:53, which was around 2.28%. Okay, so this is what it is. Yeah, let me go back to the instances. One instance is running over here. Okay, and then we are able to see the percentage, CPU utilization percentage over here. Okay, yes, so it is now most recent one. It is, I think, lagging behind like 1 minute or so. 11:54 is the local time over here, so it is showing around 0.33 percentage of usage. So let me do some bad things with this. Okay, so let me see where I am. Okay, okay, no problem. I will create it here. So let me call it as kill cpu.sh. So I'm just creating a shell script for myself in which I'm going to kill this server. Nothing fancy, simple while loop. It's an infinite while loop which I'm creating, which will keep running and is going to kill it. Okay, somehow I'm not able to paste my commands over here. So what I will do quickly is I will connect from my local machine with this server. So that is something which you may not be able to see, but after creating that file which I was trying to create, then I will show you all. Just give me a minute. Okay, so I'm using my own terminal on my local machine and I'm connecting to this recently launched server. Why I'm doing that? Because I'm unable to copy uh, the instructions which I need to pass in my shell script in this window. Okay, so I'm doing it from my local machine. Once I'm done, then I'm going to show you all. Okay, so I have created, let me just show you. Okay, so this is the file. Okay, instead of writing, I just wanted to copy paste, so I've done it from my local machine. So let me close my terminals from my local machine so that they don't distract me. Okay, so we have done this, so we are going to run this. Let me make it executable if it is not. Yes. Okay, so we have created a infinite while true loop, hoping that this is going to shoot up. Okay, so I'm sure it is going to take few minutes for it to start shooting up. Okay, once it starts shooting up, then what we should be able to see is we should be able to see another instance getting launched. Right now there is only one instance which is running, right? And this is being monitored by our auto scaling group. So it is quite less now, but it is actually showing there is a lag of almost a minute. So I'm still not able to see a jump. I should be able to see in some time. Okay, so what we will do, just to save some of our time, we'll just proceed with the lectures, the theory part. We'll just after 5 minutes, we'll come back to this. Okay, so let me continue so that we are able to save time. So we will do that after this. So after having done the lab, so the next topic which we want to touch upon, so we'll be exploring some concepts again. So the first concept which we want to touch upon is a concept of, or rather it's not a concept, it's a in architecture, more to say, monolithic applications, right? So everybody might have heard this buzzword or keyword or whatever you want to call it, like it's a monolithic application, that is why it is doing this, that. So what exactly it is, right? So for sure, the bigger applications, enterprise applications are built up of different components, right? The databases, user interfaces, right? Different databases, servers, all those things, right? And these components, like as shown in the diagram, they talk to each other, right? They are coupled to each other, right? When I say coupled, they talk to each other, they transmit data, they fulfill requests of each other, right? So if they are very tightly coupled, right, if they are talking to each other in a very tightly coupled way, right, so we call it as a monolithic application, right? Definitely the very big side effect of having a monolithic is if one application which has got 4 components, it fails, or if rather one component of such an application fails, a whole of the complete application with all its feature, they completely fail, right? So that's what the nature of typical monolithic applications are. If not monolithic, then we can have microservices architecture kind of a thing. Okay, before jumping to microservices, I will do a quick check. Oh yes, everybody would be able to see there is a big jump happening around 95%. Okay, and we should see another instance kicking in. Yes, okay, you can see 2BDC1. This is another instance which is kicking in because on the server which was being monitored, it is now plateauing. It is going to 100%, right? So the rule which we had created was just cross the 10% threshold and launch a new server, right? So we are seeing a new server being launched and it is in initializing mode. Now let's quickly look at what has happened to the activity. So if we look at the activity around 11:48, yeah, so it is saying that there is a difference between desired and actual, right? So what happens is, what it does is, whenever it sees that the CPU policy, right? So if you will see over here, this one, CPU policy changing desired capacity from 1 to 2. So the CPU policy which we had created, right, it's a scaling policy which we have created. So because of that thing, the desired capacity has been increased from 1 to 2 and it is launching a new server for us. Okay, so that is where we are able to see another server being launched. Okay, so initially we had 395, now a new server has also come. Cool. So we can now safely stop this, and after some time this load is going to come down. So for this practical lab, I have not configured a scaling in policy. Okay, so what I mean by that is, we can create two types of policies, right? Scale out, scale in. So scale out means whenever demand is heavy, you scale out, meaning you add more, right? So right now it added one more. Now when the demand goes down, it has to automatically come back, right? It has to scale in, it has to remove the additional server, right? So for this demo purpose I have not created, but definitely it's very easy. We can create such a policy, and again when it senses that the CPU utilization is coming down and goes down below 10, it is going to remove one server from here. Okay, so that was the lab. Right, you can see the graph coming down over here since we have stopped that kill CPU script, so it is now coming down. Okay, so we can also create one more kind of such a policy. When it comes down below 10, it should remove. Right now it will not remove, it will have these two servers running. So this was the lab. Hope you all were able to follow. So let's go back to the discussion which we were doing. So we talked about a monolithic way of a monolithic architecture of creating applications. Definitely when it's the just opposite to it is the microservices way, right? So in microservices what we do is whatever the different components we have, right? So they are not tightly coupled to each other, right? So what it means is even if one component fails, other components don't fail. So there is a very nice example which Priyadarshan gave me yesterday, is of a food delivery app, right? So for example, you are ordering food, let's say from Zomato or from Swiggy, then they have different features, right? So one feature is, of course, we are interested in to get our food delivered, right? So another feature is that they have these notifications which are coming out that your food is ready, it is being dispatched, it is in en route, all those things, right? So let's say for these notifications they have a notification type of component which is built on some messaging system or something, right? And then there are some other parts of the application as well. Does it happen that if you don't receive notification because that component which was responsible for sending notification, maybe if you don't receive notification, your actual food is not going to get delivered? It usually doesn't happen, right? So that's what is meant by fault tolerance. That is what is meant by even if a single component is failing, other components still continue to work because they are fault tolerant. The fault is isolated. Why it is isolated? Because they are loosely coupled. The design, the architecture of the whole system is in that way that the fault doesn't travel from one piece to one component to another component. So that is the importance, so that is the meaning of microservices kind of an architecture. Okay, third thing, again, concept alert. So we just spend few minutes on event driven architecture, right? So I'm just reminding everyone why we are understanding this, because we have got some new services which we need to understand from AWS. For understanding those services we need to know some concepts. That is why we are spending some time. So event driven architecture, very quickly we will try to just revise. There could be different types of calls happening, right? So when I say calls, I am referring to API calls which are happening, right? So those could be of two nature, right? The nature could be two types, right? Either it's a synchronous or asynchronous, right? So synchronous is, right, I give a call. Let's say I am logging into Facebook, right? So when I'm trying to log into Facebook, the web page waits for a response to come back from server, right? So it's a synchronous way. The caller of the API has to wait for a response from the server, right, for that much period of time. So it's synchronous, right? Asynchronous is where I have requested from you for something from you, but I don't wait for a response. Instead, I keep on doing what I'm doing. Once whatever I asked you, once it is ready from at your end, you come back to me with that, or you give a signal to me that yes, it is ready, and then I can come back to you and take it. So that's what is asynchronous way, right? So how does it fit in event driven architecture? Is event driven architecture is mostly asynchronous, right? So it is mostly through events through which the components communicate, right? Why it is important? Because when we just spoke about microservices, right, so there are different components which are not loose tightly coupled, right? One component is here, another component is sitting on other server. So how do they communicate? So one way is definitely is through event driven architecture way. So one component is going to shoot an event that okay, I am done with this. Second component can listen to that event and can do whatever it has to do. Why event driven? Definitely it's loose coupling. right? Different components can scale independently, right? Scale independently. So for example, I have to send out many notifications, so my notification component is different, and let's say my billing component is different, right? So when I said these components are different, what I mean is the application, not only the applications are different, they are sitting on different servers. So I can just scale my notification component or the notification application or the notification service, right, without scaling my other pieces, other components of my complete application. So I can scale different components independently. One good another advantage is agility, right? So I can be agile, I can keep on adding new components which have to listen to these events which other components are generating. And of course we spoke about fault isolation, right? So one component is down, that fault doesn't go to other parts of the component. Very quickly we will see, this is an example which we're just talking about. Customer gives an order, the cashier gives the order to barista, it prepares the order, and the drink comes back to the customer, right? So another example, what can happen is customer orders, the order goes into a queue, right? So now this person and the barista, they are not directly talking to each other, right? So they are talking through a mechanism which we can call as a order queue, right? So the order it places in a queue, the barista retrieves the order from the queue, makes the drink and gives to customer, right? So in the previous example, what was happening was there is a direct communication happening between the cashier and the barista. The cashier is directly giving an order to barista, right? Now with event kind of an architecture, or with queue introducing queues kind of an architecture, what we have done is we have decoupled these two entities, right? In this scenario these two are humans, so I will call them as human. So they are not talking directly to each other, they are talking to each other via some different mechanism, right? So that different mechanism could be an event, the different mechanism could be a queue, right? So it's a simple queue, order goes into a queue, barista retrieves an order and then makes it, right? So again, it's a very good way. It's not a synchronous way. The cashier is not waiting for barista. It keeps on taking orders from the customers. It places the order into a queue, and without even checking or worrying about what barista is doing, or has he or she picked the order, the cashier can service the next customer, right? So again, it's an asynchronous way. Instead of events, what the mechanism which we are using is queues. So with these concepts in hand within our mind, let's just quickly jump into the next service. Okay, so again, it's a service from AWS. It's a simple notification service. Okay, so simple notification service it's a publish subscriber model. So what happens is, in SNS, in AWS SNS, we can have topics and we can have subscriptions, right? So we can create a topic and we can have publishers publish some message to that topic. Okay, and then we can have subscriptions going out from that topic. Okay, so what will happen is those subscriptions could be of any forms, right? So for example, you want to say that we have this we are having this training, right? So as a trainer, I want to shoot out a message to all the participants, right? So I create a new topic, uh, 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 cloud practitioner topic kind of a thing, right? And I am the publisher, I will be going to publish some messages, right? And all the participants can subscribe to this topic. Okay, so once this subscription is done, right, so whenever I am not bothered whether this message is going to go to 100 people or 200 people, or what happens when new people are joining or existing people are going out. As a publisher, I am going to publish this message only to this topic. Okay, so I publish this topic. This topic senses or checks or sees that, okay, these are the subscribers to which this message should go out, and then this message goes out to all the subscribers, right? So this is in very simple way. I have just explained what is the publish subscriber kind of a model. So AWS SNS is a very good service which helps us achieve this kind of a design. Okay, so two concepts are very important. There is a topic concept and there is a subscriber kind of a concept, right? In SNS, we can have different types of subscribers. Okay, so one subscriber could be like, we want to send SMS, right? So the nature of their subscription could be SMS. The nature could be email, right? Since we can have other different type of subscription natures as well. So for example, I can have an HTTP API call which I want to make whenever somebody pushes a message to this topic, right? So there could be different types of subscriptions which can happen, right? So essentially this is the simple notification service. Again, it is going to help us. It can help one person who wants to develop those kind of architectures which we just spoke about, right? After this we have AWS SQS service. Again, it's a very key service from SQS. It's an SQS. It's a queue service. Okay. Again, the example which we saw. So it offers a queue. It kind of so what we can do is we can have two entities. One entity, by entity what I mean is a software application. So it can push messages into that queue, and from other side there could be a software application which starts reading those messages, right? So again, it's a decoupled way, right? Both these two applications, which is publishing a message, creating a message, and one which is consuming a message, they are not required to know the existence of each other. They are not directly talking. They are talking via queue, right? And I can scale them independently. I can create more software applications or processes which want to process these messages, right? So again, it's a very important service from AWS. It's a managed service. Again, what is meant by managed, I'll just repeat. What I mean by is, I don't worry about what is the software application running behind SQS. I don't worry about what kind of servers it is using. I don't worry about if I am putting only one message per minute or I am putting 1,000 messages per minute. Okay, I as a user of the queue, I am only going to put messages and take out messages. If the demand or if the frequency of pushing messages goes up or down, it is AWS headache to keep up the capacity side of things, right? So that is what is meant by AWS managed service, right? And I'm just creating a difference. EC2, right? EC2 service, right? In EC2, when I'm launching an EC2, it is not a completely AWS managed service, right? Because I choose what kind of configuration I want to, right? And once I choose whatever application I'm running, it is using that kind of configuration, that kind of RAM, that kind of CPU, right? Of course, there are ways like we saw auto scaling wherein we can create more, but all these things I have to do. But when we are talking about 100% AWS managed, I need not bother about any of these things, right? So in some way, what is happening is we are trying to these category of services, we can also call them as serverless, because for me, I don't know, because for sure when it is SQS or SNS, there is a software application behind it, right? And if there is a software application, there must be some servers on which AWS is running those things, right? But as a consumer of these services, do I really care? I don't care what kind of server AWS is using, how many servers it is using, when the demand is increasing, what it is doing. I don't really care, right? So it is AWS managed 100%, and also it is serverless for me because I am not required to bother about the servers, right? Okay, so we'll just see about the queues. So one important difference between SNS and SQ is that we don't lose messages which are going into queue, right? Of late, SNS also come up with a feature where we will not lose messages, but from a very long time this was one key distinction. Second is the size of the message, right? When we are using SQS, we can have a bigger size of messages which we can pass, right? And then we can use SQS, right? And definitely it gives us a decoupled approach, right? So with this we will go to next concept. Again, it's a concept alert, serverless computing. I hope that we touched upon when we were talking about SNS and SQS. Again, the term serverless means is your code still runs on servers, but you are not required to bother about what kind of servers, how many servers I need to provision, I have to manage those servers, what is happening, what is not happening, all those things I need not to worry about. So that is what is meant by the term serverless computing. Okay, so with that understanding, we go to next service, which is more very much falls into this category of serverless, because this is also known as a function as a service, right? So there is another phrase also for AWS Lambda. So we'll be doing definitely lab on this, but just before doing a lab, AWS Lambda, what it does is you can have a function with you. So let's say you want to create a very simple function where you take two numbers and add them and return the sum. right? If you want to create a function, what you would do? So if I am a Java programmer, I will create a Java class, right? And then I will run the Java class in a JVM. Where will I run JVM? I will run JVM on a machine, on a server, right? So all those things I need to worry about, right? But when it comes to 100% serverless or a different term, function as a service, so in this situation, I just know that I will create my Java class, which will take two numbers and will return the sum of that numbers. Where is the JVM? I don't care. I'm not going to install it. I don't worry about it, right? Where is the server? What is the configuration? I don't care about it. I am just interested in writing this function, and this function should be executed. And why should I be bothered about how much CPU for which I'm paying? Why? Because there could be an EC2 server, right, on which I am putting this function, and it gets executed only once in a day. I will repeat the scenario because this is very important for every one of us to understand. I have a Java class in which I have a function in which I just return the sum of two numbers which come as an input. I put this in a JVM, I put this on a EC2 server, and I keep it running. So what will happen is, for in 1 month around almost there are 750 hours, right? So for whole of 750 hours, I am running this EC2 instance, and I am required to pay that much worth of money to AWS. There is a possibility that this function was executed only once a day. So for whole of month, there are only 30 times this function was executed, but I was required to pay for whole of 750 hours. So this particular situation is very well handled. You know how the pricing is handled by AWS Lambda. So AWS Lambda says, you just come to me, you just give me your function, and the most important thing is I am going to charge you only when your code is running. So in whole of the month, if you ran your function 30 times, you have to pay correspondingly only for 30 times. Okay, so isn't it wonderful? I mean, not only I'm not required to bother about servers, JVM, nothing. I'm only interested in my function, and also from a cost saving perspective, it is extremely great, right? So that's what it is, AWS Lambda. So this is what it is. So we are doing a lab. Very quickly we will be doing a lab on this, wherein we will be seeing how Lambda is running. Pridarshan, it's 12:20. Should we do this lab, or what are your thoughts? Because
Yes,
we have to complete infra, networking, and storage.
yes. I would recommend, let's continue with the flow, continue with the lab as well.
Okay,
Okay, as
okay.
it is, important.
Sure thing,
So,
sure thing.
yeah.
Okay. So I'll just quickly go to the lab, and then we will see this happening. So, okay. So again, this is the search bar where we can search different services. So I'm going to search Lambda. Let me close other tabs so that they don't confuse us. Okay, so it says function. So I will create a function, right? So that's what I'm interested in. Okay, so let's say hello world, right? So that's what most of the people do. So I am going to leave other settings because those are slightly advanced settings as is. By default, AWS has chosen some values for that. Of course, we need to tell the runtime, like I am writing this program in Java, in Node. There are many languages which are supported: Go, Python, Ruby, .NET, right? And specific versions, right? So many things are supported. I am not going to write a heavy program. I am just using Node.js as the engine or the platform on which we will be writing some code. Okay, so let's create a function. So I clicked on create a function. Okay. Yes. Sorry about that. Okay, so this is the screen which opens up once I have created my function hello world. You can see there are some triggers and there are some destinations as well. So what is a trigger? So trigger means, since this is an AWS service and there are some other AWS service, so there is a very seamless integration which can happen between different AWS services. So what I mean by this is I can add a trigger. So what I mean is these are the different services which can send a trigger, which can invoke my Lambda function. Again, there are many services from where it is service supported, right? So we are going to see how it gets triggered from API gateway, that we will see in this lab. Okay, again, same thing, destination. I can create a destination. So for example, if I have to pull records from my database, right? So one destination I need to add in Lambda is database, right? So I can add some destinations from where either it has to pull some records or fetch some information, or the opposite, where after the Lambda is executed, it wants to send out some event or some signal to another AWS service. So using a trigger or destination, I would be able to do that, right? So let's come down. So again, it's not a very heavyweight thing. It's a simple IDE which comes up, right? So we can create simple programs, right? But if we want to have detailed, I mean heavy programs which we have created of good size, and if we are using some other IDs, we have some program on local, so we can also upload a zip file as a program or function which we want to execute. So right now I won't go into Node.js concepts. So basically this is a function which will get executed, and this is the response which it will give. It will say it is going to return a string hello from Lambda. Okay, so let's quickly test it out. So I'm just testing out over here. Okay, so I'm just creating a test event. So this test is happening just from here itself, right? So I'm not invoking it from outside, I'm just executing it here. So it gives me a response that okay, hello from Lambda, right? So I can create whatever function I want to. So the example which I was giving, take two numbers, return two numbers, that also I can create. But right now I just want to show you this how the Lambda is going to integrate from API gateway, and then how can we invoke it, right? So that's what I'm more interested in rather than creating a program. So let me quickly go to API gateway, right? So on the slides we have not yet covered API gateway, but again, just quick intro about API gateway. API gateway is again a AWS managed service. So its name is actually an API gateway. What it is, it's an API gateway which is provided by AWS. What is an API gateway? API gateway is a software application through which different consumers of your REST APIs or different type of APIs, they can invoke your APIs, right? It behaves as a gateway to your different APIs. So that's what conceptually an API gateway is. It has got many advantages which you can learn offline by going through different documentation. So let me go to AWS API gateway. So what right now we are going to demonstrate is we are going to create a REST endpoint for ourselves. When we call the REST endpoint from internet, that REST endpoint is going to call our Lambda function and get this response back. Okay, so I'm going to create a REST endpoint. Okay, I'll click on build. Okay, so instead of doing all this, I'll say new API. I'll say the name of my API is hello world. Okay, so I say create API. Okay, definitely in REST world we have resources. All right, so I can create a resource. Okay, let me create AWS. So that's the resource which I create. And then on a resource, I can create different methods. So let me create a get method. Okay, so now I have created an API, but what will that API do? So I have to integrate it, right? So I integrate it with a Lambda function. So again, so what is happening is I am adding a trigger. Okay, so I'm adding a trigger from API gateway to Lambda. I can do it vice versa as well. I can go to Lambda and I can add a trigger from this API gateway. Both the things are possible. So I have added this trigger. I click save. So what it gives is it says that you are giving permission to API gateway to invoke your Lambda function. I said, okay, that's what I want to do. Okay, so yes, so it has created an API bit for me. Okay, and I have told API gateway this API when is invoked, it should call my Lambda function. Now what I will do, I will deploy. So again, these are the concepts of API gateway that after creating an API, I need to deploy it, right? So don't get too much distracted on the steps which I'm doing. Just try to focus on the concepts which I'm trying to tell. So let me deploy this. Okay, so now, so this gives me a invocation URL. It's again a get API endpoint, REST endpoint, which has created for me. So if I go here and I'm on the internet, if I do this, I get a nice hello from my Lambda. Okay, so what has happened is I hit this endpoint, it goes to API gateway. API gateway sees that, okay, this is on resource AWS, and then it's a get call. So it goes to Lambda, invokes it, gets the response back, and gives the response back to my client, which is my browser. We can do a quick check. Hello from Lambda, stay at home, folks. So I'm going to change my message. Again, I'm changing in my Lambda so as to ensure that, it's actually working. So I save the changes. I again go here, I refresh it. So I can say I'm sorry, I misspelled the word stay, but we are able to follow along, right? So the message is changed now. Okay. So again, I mean, you can see this, there is no server involved, right? I not create an EC2 instance, nothing. I simply had my function. I used Lambda, created a function, and I used API gateway. I created an API, and that API is working. It's so simple. Okay, so that is the end of our lab. So let's move forward. We have a lot to cover. Okay, so with that lab ending, we move to the next topic, which is virtualization. So I would request help from my friend Pridarshan to take us through next 4-5 slides for this concept of virtualization and the related services. Over to you, Pridarshan.
Thank you, Ankit. So till now, what we have seen, AWS, it's all about doing or getting all the infrastructure without having any kind of configuration or any kind of real buying a hardware or nothing we need to do. Just you have used your computer and a browser and a service that is provided by AWS. So this entire concept, whatever you have seen till now, the backbone is virtualization. So there is a reason we are talking about it. In next slide, we will talk about the future of virtualization. So this virtualization enables you to create servers using a software which we are calling as a hypervisor. So we install a hypervisor on top of a server. That is the server or the host that you see here is a real hardware, and hypervisor is a software. So this hypervisor enables you to segregate this hardware in such a way that the end user will never know that they are running a software based system, or they are actually using the hardware. So when we have a hypervisor, we can segregate our entire hardware. Let's say, for example, you have 16 GB of RAM, you have 10 cores or 10 or 12 cores of CPU, and you have 100 gigs of storage. So if I install a hypervisor, so what I can do is I can create a system of 4 GB RAM, 2 CPUs, and 20 GB of storage. Similarly, I can create another one based on the amount of resource I have. So this is we can able to do using the hypervisor. So the hypervisors in the market are VMware, Zen, and KVM. They are the leading vendors who are providing hypervisor. So whatever you have seen in AWS uses Zen and KVM for the hypervisor. So now, if you previous slide, you have seen that we have to install a hypervisor on top of the server. Now, next slide, now please. Okay. Right. So that actually triggers a problem, because there again, you are installing a separate OS on the virtually created system. So that means the hypervisor is also based on operating system, and on top of that, you are again installing an operating system. So unnecessarily, the operating system will consume the resources that you are assigning to the virtual machine. So to avoid that kind of concept, a new concept has been launched called containers. So in containers, either you can have a hypervisor, on top of that a guest OS, and we will install a Docker engine. Actually, Docker is the one type of the container available in the market, which is very much popular in today's day. So using Docker, what you can do, we do not, again, no need to manage your operating system here. Directly, what you can do is deploy your applications, package your applications with the minimum required libraries, and deploy that on a container. And the additional benefit of container is they are host independent or server independent. You can run any application anywhere, whether it is any kind of OS, like whether it is a Linux, whether it is Ubuntu, whether it is Windows. It doesn't really care. What it knows is you should have the Docker engine running. So you take your application and run it anywhere. Additional thing is, in virtual machines, the migration was difficult. Means if you have installed one application in a virtual machine, the overall size is very much huge. It will be in GB, right? But in container, that has been drastically reduced to MBs only. It may be 100 to 200 MBs based on your type of application. It contains only the application size. The content of the application will be packaged along with the libraries. So that is helping a lot to more quickly deploy your application. So all this concept will be helpful when you, after your cloud practitioner understanding, you learn about DevOps. So there you will really understand how the containers are useful to quickly go to the market. As an example, what I will tell you is, we have already learned the scaling, auto scaling. Those are with servers. So similar example I can give with containers. You must be, most of you, I believe, cricket fans, and must be using, whenever you don't have a TV to watch, you must be having a Cricinfo site where you are watching the score. Maybe right now they are live streaming as well. So think at some point, like, if it is a match between South Africa and Australia, how many viewers are there? The number of viewers changes when the match difference, like, think about India and Pakistan, just a match. There will be more increase of viewers. The viewers will be like, you cannot imagine the number of viewers when a match is happening between India and Pakistan, and that is a World Cup final. You cannot imagine how many viewers will watch. So how to maintain all this sudden spike of the requirement of infrastructure? How do you stream? How do they stream the live video without any interruption? Because they are able to, the application is running on a Docker machine or Docker engine, and they can quickly, within seconds, they can, not even in auto scaling, you might have seen it is taking a minute or so to get started, right? The initializing the system takes a minute or so, but in Docker engine, that will be in fraction of seconds, just as quickly as possible can be done. That is the benefit of container. Yeah, next slide, please. Right. So basically what we discussed is the same image that I showed. I told you the concept. We have a server, the OS, and the applications are only packaged, and we can install multiple applications using the container. Yeah, next please. So the upscaling, or scaling, is as quick as thousands of container you can run in one host, whereas we have very limited number of virtual machine we can run on a particular server. But when it comes to container, multiple containers can be executed because they are small in size, they take less resources, and the storage usage, or the amount of storage they need, is very less as well. So that helps us to run multiple or hundreds of containers in one server. Next, please. So that was the concept of container. Now this Amazon provides you a service called Amazon Elastic Container Service to maintain or to deploy the containers live. So this is a highly scalable and high performance container management service provided from Amazon. This also supports, as we just talked about Docker, the Docker architecture or the Docker engine is presently supported by Amazon ECS. So now next, please. So when this container comes into picture, now we are talking like, so many containers. How do you manage them? It is not like a system or so you just go and log in and manage, right? So when there are more difficulties come, we are talking about hundreds of containers. Now we also talked about the microservice architecture. Think one microservice architecture has multiple components. Each component can be a Docker container. Now think in a large scale. You have one application running, the application with multiple containers is running for one region. There is another set of, so the same application is running in another location for a high availability. Means you ensure that if one region server goes down, you can provide the support from the other region server also. Like that, you have created multiple the application in multiple regions. What will happen in that case? You are dealing with more and more containers, and the management will get difficult, right? So to avoid or to better manage the container environment, Amazon also provides you another service called Elastic Kubernetes Service, or in short EKS. So it is nothing but based on the open source Kubernetes, or K8, what we call in general, based on the open source version of Kubernetes, and they are providing you as a service so that you do not need to pre-configure or recreate the infrastructure yourself. This is pre-configured. You can easily go and just create the cluster where your application is going to execute on the cloud. Yeah. So these are the container-based services. These are advanced level, concept services. When you are going to learn about DevOps and all, you have to explore these services. So for now, we are informing you this because in the exam you may get a question, what service does what. So similar to Lambda, where we were doing our infrastructure as serverless, here Fargate is one of the service which provides you ECS, or the container service, and the Kubernetes service for a serverless maintenance. You do not need to handle any kind of infrastructure using Fargate. You just focus on deploy your application and create your applications as better as you can, right? So this is the Fargate service that you can be used for ECS, serverless ECS and EKS management. Yeah. So that's all, guys, from my side. Over to you, Ankit, again.
Okay, thank you, Pradershan, for taking us through virtualization and these concepts. Okay, so we are done with module 2. I hope that it was interesting and you folks were able to learn a lot about it. So now we are moving to our third module, which is global infrastructure and reliability. So this is our third module. So let's start with this. So just quickly checking what are the learning objectives, what are we going to learn. So we are going to learn about global infrastructure of AWS, what are the benefits, some concepts with respect to availability zones, edge locations, and different ways of provisioning AWS services. So these are the learning objectives for these modules. Let's go ahead. So the very first thing which we need to understand, the basic building blocks. So AWS got two concepts. First concept is a concept of region, and the second concept is the concept of an availability zone. So what is a region? Region is a physical location around a world, okay, where there is a group of or a cluster of data centers present, right? So I'll just repeat: region is a physical location anywhere in the world, right? They have definitely predefined, identified, and build up these data centers, okay? So in a specific region, in a specific physical locations, that we can call as region, right? What is an availability zone? Availability zone is a data center, a specific data center present inside a region, right? So the actual physical building, which has all these servers, which we can call as data center, is being denoted as a availability zone, and a group of availability zones together as a cluster are being referred to as a region, right? So for example, right now, the labs which we were doing these labs in the Mumbai region. Okay, in Mumbai region we have got 3 different availability zones, and the AWS has identified that Mumbai as a region, right? So how to determine, right? So for example, if you are trying to create your own, you have an idea, you are starting your a business and you have to create an application. So what region you need to choose, because that is the very first thing which you would want to do before you even start launching EC2 server or anything, right? So you have to launch these resources in a specific region, right? So what you will consider, first of all, definitely, as I was talking about, there could be some compliance or legal requirements, right? So for example, there could be some requirement from the compliance perspective that the data of the customers should reside within the geography. So for example, in India, some government authority can say that the customer's data should reside in a data center which is physically present inside India. So this is a non-technical requirement, this is a compliance or legal requirement, right? So if that is the case, definitely you cannot do anything. You will have to choose a region which is in India, which is in Mumbai, right? Second thing which you can consider is with respect to proximity, right? The distance which you have between your customers, right? So even if you don't have such constraint with respect to compliance or legality of things, if your most of the customers are residing in India and you choose a region which is in the US, so what it means is you have chosen a region in US and the data center or the physical servers are in US, right? So definitely it may not be a very good choice, because there would be a lot of latency when your customers are accessing those services, your web pages, your data, everything is coming from US, right? So it may not be the best choice, right? So this is also one factor which you can consider, right? The third thing which you also need to consider is available services, right? So this is another interesting point, that whenever AWS is launching any new services, right now I think it's like 300 or 400 plus services which AWS has already launched. So when they are launching these services, usually they don't launch these services in all the regions, right? So what they do is they pick and choose specific regions in which they want to launch a new service, they want to experiment how their service is behaving, and then they slowly make these services available to other regions. So definitely you have to consider this parameter as well. And also, last but not the least, pricing, which is also another important factor. Yes, of course, the pricing of each service is different in a specific region. So the cost of running one server in Mumbai is different from the cost of running the same type of server in US, right? This is how AWS is structured. So these are the 4 parameters through which you can determine, or you can decide what should be my region in which I should be creating my IT resources, my servers and all, right? Just taking a very again, just revisiting this concept of availability zone, so that it is very clear, because there could be questions on it, like what is an availability zone. So in this diagram you can see very clearly it is talking. So these yellow colored dots or these blocks, these are the regions. So for example, we have a region in North California or Oregon or government cloud USA West. So these are the 3 different regions. Each region has a collection of actual data centers which are the availability zones. So for example, North California, there is a code name for it which AWS has given. The code name is US-West-1. So this is a region. It has a collection of actual 3 data centers. So we can say that this region has got 3 availability zones, right? So definitely the exam is not going to test you that how many availability zones are there in North California. So that is not the point. The point is you need to understand the concept of a region and the concept of availability zones, right? So that is what it is. Now, uh, uh, why different availability zones are important? Because when we are talking about launching an instance, right? So when we are launching an EC2 server, right? So we are always launching an EC2 server in a specific, not only a specific region, but also in a specific availability zone. So for example, I have chosen for my application that I will be launching my EC2 instance in North California region, and the availability zone that I will be selecting is US-West-1A. Okay, so 1A, I mean ABC are the three different availability zones available. So that I do, right? So what happens is, definitely it's a physical data center, and in this world nobody is, nobody can be can have no failures, right? Even AWS has failures many times, right? So let's say there is some problem in this data center. I am using these two terms interchangeably, data center and availability zone, right? When you have to speak a language which is more AWS oriented, so let's choose the word availability zone, but for understanding purpose it's a data center. So let's say this availability zone, which is a actual physical center, it has got servers, so it goes down for some region, right? Then what happens, right? So for that purpose, what we can also do is, in the very first step, instead of having one EC2 instance in one availability zone, what I can do is I can have two EC2 instances deployed or created in two different availability zones, right? So this is again a good design approach. What I can do is I can have my web applications sitting in those two different servers, and then I can have a load balancer, right? There was a diagram in one of the older slides where there was a load balancer and there was a fleet of EC2 servers under the load balancer. So when I'm creating a fleet of EC2 servers, I can create that fleet, I can create that more than one EC2 servers in different availability zones. So in the event of a catastrophe, or in the event when there is a problem in the complete availability zone, one availability zone in the region, another availability zone is available, and my business or my application is not affected. So that is one good design approach of, why we should use different availability zones, right? Right. Very quickly, we'll be touching upon another important thing, which is an edge location. Okay, so edge location, it can be considered as a cache, right? So edge location is kind of a cache where it can keep or maintain copy of your content which is closer to your customers, right? So what can happen is, in my own organization where I'm working, so our the primary region and the data centers the availability zones which we have chosen is in America, and it's in US. Okay, so but our customers are global, but 95% of our customers are in US, so that is why we have chosen region as US. But in these 5% cases, there is a chance that, in India or from Australia or from these areas, these regions, there are customers who are trying to access our application which is hosted in US. So what happens then? What can we do to make the experience of these customers better? So there is a concept of edge location. So what it does is, there are edge locations across different regions across the world, right? So what they do is, whenever the data is flowing through them, right? So there is a customer here who is trying to access some content, and that content is coming from this region of world, right? So it's a video which is coming in. So when it comes and the customer starts seeing it, this specific service which is called as edge location, it's actually a physical thing. So it caches that video, so that next time if a customer asks for the same thing, different customer, the same customer, the it will be served from this edge location, and the request will not go to the uh, region situated in North America, right? So because of this, the latency will be low and the customer experience will be better. So this is a concept of edge location. Okay, now we discuss different ways. So there's another objective, how to interact with AWS services. So this is the first way which you have been seeing in the different labs. I have been logging into AWS Management Console. It is a web-based interface wherein, we can access, we can create new services, we can manage those services, all those things, right? Another way is through command line interface. So what we can do is, through command line we can do mostly all of the things which we want to do through user interface, right? So it depends on your preference, how you want to do. If you want a user interface, you can use this. If you want to invoke the same things, for example, if you want to create a lambda function, you don't want to use UI, you can use this through a command line interface. So command line interface, the tool's name is AWS CLI, AWS command line interface, AWS CLI. So that you can install on your machines and using a terminal or Windows PowerShell. So you can, from there you can issue specific commands on your on the command prompt on the terminal, and then you can create those, create or manage or access those AWS services. Okay. The last way is software development kit. So in both these situations, I mean, for AWS management console or for command line use case, command line interface, the primary user is a human, right? So for example, we were doing some labs, so we are trying to play with these services, right? So what happens when we want to use these services internally? So for example, I have a software application. We were talking about SQS, right? So I have a software application. It wants to publish a message to that queue, right? So here the user or the entity is not a human, right? It's a program which wants to interact or rather integrate with the queue. So in these situations, there are software development kits. It's like APIs, different APIs, software development kits, which are available for various, or rather I would say for maximum of the programming languages available. And then you can use those SDKs, you can import those SDKs in your programming environment, and then you can create those clients. So for example, if I want to, I'm using Java and I have to push a message to SQS, I can use the Java library for queue. I can create a object of that specific SQS. While I'm creating an object, I have to pass certain parameters like what is the unique identifier for that SQS, and then that SDK, that library exposes different methods for pushing the message, for obtaining that message, all those things. So these are the three different ways through which we can do that, right? Now we will be talking about different service of AWS, which is called as Elastic Beanstalk. We are not going into much more detail because it's only required for you to know that such service exists and what is the purpose. So Elastic Beanstalk is definitely a different service altogether. It eases the creation of different creation and the usage of different services even further, right? So what we do is, so as a developer, I have an application, I have the source code of an application which I want to run, right? But I don't want to get into which type of servers, right? The configurations, the instance types, creating auto scaling, right? So the lab which we did, right? So you might have noticed that I did some amount of preparation before, and I created launch configuration, I created auto scaling groups, I created some CloudWatch alarms, all those things I had to do, right, before I was able to show you that lab. So as a developer, I'm saying no, I'm just interested. I have created my application, it's in Java, and I just want to give this to cloud and let the cloud figure out what all it wants to do. Definitely I'll be giving some hints like just I want high scalability to be the scalability should be good. So those kind of inputs I will give, but all these things should be automatically configured. All those services should be automatically procured for me, provisioned for me. So that's where AWS Elastic Beanstalk comes, right? So we provide the code, we provide some configuration settings, and it will do all the things. It will provision EC2 servers, it will do load balancers, it will do auto scaling, it will create all the CloudWatch matrices and all these alarms and everything it will do, and you are ready to go. Okay, so we are not doing any lab, it's not required. Only thing it is required is such service exists and what is the reason and how what is the objective, what it tries to solve. All right, so this is the problem which it tries to solve, and these are the benefits. On the same token, we are again looking at a different service, which is AWS CloudFormation. Okay, again, the problem it tries to solve is of not of developers but of the system administrators, which who are responsible for building or creating different environments, like so dev environment, staging, pre-prod, prod, pre-prod 1, pre-prod 2, user acceptance environments and different environments, right? And then not only you have to create those environments, but you have to remember like what you have done in a specific environments, right? Which version of what you are choosing, right? So it's very messy, right? It can get very messy at different times, we all know that, right? So here comes AWS CloudFormation. The thing which is it's trying to do is infrastructure as a code, right? So the concept of infrastructure as a code is that you want to have your infrastructure. When I say infrastructure, these are the same IT services, right? Storage, network, CPU, RAM, all those things, and right. And other infrastructure could be like, when it comes to AWS, load balancers you want to use, auto scaling you want to use certain SQS, you want to use some alarms. So all those things can be termed as the infrastructure or the IT resources which I want to use. So instead of doing all these things manually, either by logging into the management console or using AWS CLI, what feature AWS CloudFormation do is we can have a YAML file, and there are specific instructions which are very specific to AWS CloudFormation. Those instructions I can write as if it's a code. Okay, I can say that, okay, I want to use a EC2 instance. So there is a specific way of putting this in a YAML file for AWS CloudFormation to understand. So I can create this file, I can have this file, and I can give this to AWS CloudFormation. CloudFormation goes through that file, parses it, understands it, and depending on what all instructions I have written, it executes those instructions, and it creates all those resources, it provisions all those IT resources for me, right? The benefit is I just have one single file. I will take this file, I will create as many different environments I want, and all these environments are completely similar, right? So it's like, I'm provisioning my resources in a safe, repeatable manner, right? So it enables me to frequently build my infrastructure application without having to do any manual actions, right? So this is the concept of infrastructure code, which is being addressed by this service, AWS CloudFormation. Okay, definitely this slide deck will be given to you when the seminar ends. So there are some additional resources which you may want to go, which will further increase your knowledge about the topics which we have covered in this module. Okay, so there are these links you can click and you can read it offline. Okay, so this is the end of module 3. Priyadarshan, if we don't have any questions, I will log into module 4. Once we complete module 4, if you say, then we will break for lunch.
Definitely, Ankit. Thank you for that. Yes. After module 4, we will, take a lunch break, and
Okay.
after that, we'll come back again. Thank you. Yeah,
Okay.
please continue.
Okay. So we are going into module 4. It's networking. Okay. Some the objectives what the certificate asks a candidate to understand and appreciate. So different concepts like VPC, virtual private gateway, subnets, AW. I'm not reading because we are running short of time and we are lagging behind. So AWS Direct Connect. So these are all the objectives which definitely will be covering in the upcoming slides. So moving forward, the very first thing which we want to understand is the concept of virtual private cloud, VPC. Right. So when it comes to building up your resources, right? So when we were launching EC2 instance, right, I will quickly show you. Will not take a lot of time over there because it's not a lab which I had planned, but just to make it more meaningful, I will show. So when we are talking about launching or creating or provisioning different IT resources, what happens is automatically when we are creating an AWS account, automatically there is a by default VPC which is created for ourselves, right? So what is a VPC? VPC is a isolated section of the AWS cloud. Okay, it's a logical isolated section in which I can have my AWS resources. So any resource, it could be Lambda function, it could be database, it could be EC2 server, whatever I am provisioning, I can provision those resources in that logical isolated section. Why do we want to have VPCs? Because I can have one account. So for example, in my current organization itself, I have an account in which I want to create two different environments. One environment I want to create for my development. Another environment I want to create for my QAs, right? And these two environments are very different environments. They need not to talk to each other at all. I don't want it, right? So what I do is I go into my account. Okay, I create two different VPCs. One VPC, again, isolated logical section. I say that, okay, this is a VPC in which I will be creating AWS services for my development environment. And another VPC I've created, which I will be using for my QA purposes. So the resources I will be definitely creating same type of resources because my application is same, but two times, once in the dev VPC and another time in my staging VPC, right? So that is the usage, right? Like, how can we use VPCs? This is one example, right? So it's an isolated section in which I can launch my resources, right? So I was just showing you the EC2. So if you are launching an EC2 over here, let me just show you very quickly. Yes. So if we look at the network section over here, it says VPC 0FE60664 default. Okay, so this is a demo account which I had created for today's training. So one default VPC is already been created. It is already selected. So what I can do is, if I want to create a new VPC, I can create, and then it drop down, it will start appearing. So I can choose, I am launching an EC2 server. I can choose which VPC I want to. Right now there is only one VPC. It is selected by default. Yeah, but so that's what I was trying to mention. Then there is a concept of subnets, right? So subnets are inside VPC. So first isolation we made with the help of a VPC. Inside a VPC, I can create different logical sections of VPC, which I can call as subnets. Okay. So again, if I again go back to my launch instance wizard, again it is available as a drop down to me. So when I am launching an EC2, I will just repeat, I am required to choose a VPC. By default, the default VPC is selected, and by default there is no preference selected for subnet, right? So what happens is, if I don't give a preference, it automatically randomly chooses subnet and launches it, right? Otherwise I can choose a subnet. Now coming back to what is a subnet. So subnet is again, it's a subsection of a VPC which I have created, right? So I can create different subnets for different purpose. Why I want to create subnets? That's the question, right? So let's see with the help of the next slide, right? So I'll just give the reference of the current application in my current organization, how we are using it, right? So in my application, for let's say for the development environment, right? So in development environment, I have got two components. We spoke about components, so I've got two components. One component is a web server, right? And another component is database, right? Database has all the data, right? And definitely I don't want my database to be exposed to whole of the world, right? I want some protection over there. I don't want it to be accessed by anybody and anyone. I just want my web application to access my database, right? Because from front end, the web server will be called, and from web server my database will be called. So what I want is, the web server which I have, it should be publicly accessible, so that people can make requests and get the data. And my database server should not be publicly accessible. It should be accessible only from my web server. So this is what my design should look like, right? So how can I achieve that? So both these servers, my database server and my applications web server, they both are in the same VPC, but they both have different objectives, right? So one way of achieving this is, I can have subnets. So I can create again two subsections inside my VPC. What I can do is, I can have one subnet as public, okay, which has to have public internet availability, and then another subnet I can have as private, which does not have any internet or public available to it. They cannot connect to it, right? So that is how I can design it. So that is where the concept of subnets becomes very useful. It's a logical subsection of a VPC, right? So again, subnet is a section of VPC in which we can group resources based on security. I had a security need, right? Or security or operational needs. It can be of public subnet or a private subnet. So this is the same exact thing which I have also done in my organization in terms of public and private, right? Now, next concept is internet gateway, right? So we spoke about that one subnet will be public, another will not be public. So how to do that, right? So how to do that is with the help of internet gateway, right? So internet gateway is a service. Again, it's a service from AWS which allows public traffic from the internet to go inside your VPC. Okay, so as the diagram says, here is a client, it wants something, it makes a call. So the call first of all comes to internet gateway, which is like a gatekeeper which is sitting on your VPC. Okay, if there is no internet gateway, there won't be any public connectivity to your VPC. If there is an internet gateway, there can be a public internet connectivity. Now what happens is, this internet gateway, it says that, okay, I have got a request from an internet. Now what I should do? So definitely there are some rules which we call as route tables. Okay, so again, I don't want to go that deep, but just giving you all, some concepts from high level. So internet gateway has some rules. So basis those rules, we can say that, okay, uh, I have one subnet which internet gateway should be able to access, but I don't want my private subnet to be attached to my internet gateway. So I'll just repeat. What I do is, when I have to make a subnet public, I attach that internet gateway to that subnet. The subnet which I don't want to be available publicly, I don't attach any internet gateway to it. So what happens is, whenever the request comes from internet gateway sees that, okay, I am attached to this subnet, I can go to this subnet. The subnet which have not an internet gateway attached, that request from internet will not go to that subnet. So this is how we can achieve this private and public subnet kind of a design with using internet gateway service. Okay. Next up, in the networking module, we have virtual private gateways. Okay, so virtual private gateways is a logical, fully redundant edge routing function that sits at the edge of your VPC. Okay, so what is the use of this? Many times we might have been using VPN, right? So we have to connect to our office networks and other networks, right? So we use VPN, we log into VPN, right? So similar kind of functionality is also supported by AWS, right? So to support a VPN, we have the service of virtual private gateway. Okay, so it is capable of terminating VPN connections from your environment, okay, to AWS. So that is what the purpose and use of virtual private gateway. Okay, next up, another service which we would look at is AWS Direct Connect. Okay, again in the networking module, this is a very important service. Why it is important? Because there could be situations where you have your application servers which are running on premise in your data center, and you want to access something which is, again, it's a hybrid model which you have opted for. So you have some application setting in your public cloud, right? So how do you do it? How do you design it, right? So from your data center, the request, or you are asking for data from the AWS cloud. So there are two options. One is, definitely you can use the internet route. So from your data center via internet, the request goes to AWS and then it gets serviced, right? Again, it is going through internet. Definitely there is an issue of bandwidth over there, and definitely it may not be very, very, very secure, right? So here comes AWS Direct Connect, right? So it's a dedicated, it enables us to establish a dedicated private connection between data center and VPC. So if you establish a dedicated connection, definitely it reduces your network cost. It gives you good amount of bandwidth, right? Because it's a dedicated connection only for you. There is no internet other data flowing, right? So the available bandwidth also increases a lot, and definitely it is slightly more secure as compared to taking things via internet, right? Now just making you understand how the network traffic is flowing inside VPC, right? So whenever we are requesting any data from any application which is hosted on AWS cloud, so whatever is happening is, these requests are nothing but these are data packets, right, which are getting transmitted on the network, right? So the data packet, so for example, if if the request is coming from internet, so what happens is, these data packets enter into VPC through internet gateway. Why? Because internet gateway is the gatekeeper for public internet, right? So it enters from internet gateway, right? After entering from internet gateway, definitely if there are any subnets which are available, which to which the internet gateway is available attached, internet gateway is going to route those packets, right, to those subnets, right? So this is how the flow would be. Now we will be talking about on top of these network packets, these data packets which are getting transmitted, what kind of security options are available. So very first security option which is available to us is network access control list. Okay, so in short we can call it as NACL NACL. Okay, so how we can understand it? We can simply understand it by imagining it's like a virtual firewall which is sitting on top of our subnet. So each subnet we can have a NACL configured, and NACL simply controls what kind of data packets can come in, what kind of data packets can go out. Okay, so we can very well specify that from what kind of different AWS services data packet come in, or from what kind of IP ranges data packets can come in. If the data packets are coming in or going out, what are the ports on which this type of communication can happen. So to that granular level we can have that configuration, security configuration, right? So again, the important point to remember is network access control list, NACLs. They are kind of a virtual firewall which can control the incoming and outgoing data traffic at subnet level. So remembering subnet level is very important. Okay, why? Because we go to the next service, next feature available, which is security group. Again, it is very much similar to network access control layer NACL, but a very important distinguishing point is it operates on EC2 level. Okay, so with the help of this diagram it should be very clear. So this is the diagram. So we have got a inside AWS big cloud, we have our own suite VPC. Inside our VPC we have a public subnet, right? And inside the public subnet we have got two EC2 instances. Okay, in this VPC we have internet gateway, and this subnet has got this internet gateway attached, right? So this is the setup which we have done. Now what we can do, we can have security groups attached to these EC2 instances, right? So I can have different configuration for this EC2 instance, I can have different configuration to this EC2 instance, but at a subnet level I can have a network access control list, NACL. Okay, so these things are not mandatory, right? Because we may have a network access control list or we may not have a network control list, right? It is optional, but we need to have a security group. By default, whenever we were launching an EC2 instance, AWS either can create a default security group for us, or we can ourselves create a security group for ourselves. Okay, so this is from the security perspective, how AWS at the networking layer gives security options. So we studied two things: NACLs and security groups. NACLs operate at subnet layer and security groups operate at EC2 layer. Okay, continuing with the networking thing, again concept alert, we are talking about domain name system, DNS resolutions, right? So it's a very simple thing. It every now and then, every moment it is happening for us whenever we are typing any IP website URL on the browser, there is a DNS resolution happening, right? So DNS resolution is simple. So there is a domain name like abcd.com or facebook.com, right? And there is definitely an IP address of a server which is going to actually serve this request, right? So for user friendliness we are using facebook.com, but eventually the system, the computers, the machines have to know what is the IP address, right? So there has to be a DNS resolution. The DNS resolution means converting of this user friendly name, DNS name, facebook.com, into a specific IP address, so that the machines, the network knows from where this request has to be served, right? As a user of this Facebook application, we need not to worry, because we just open the browser, we just type facebook.com, we don't even know what is that IP address to which it has been resolved, right? But it has been resolved to a specific IP address for us by the networking layer and the different machines, right, by the DNS resolver, and then the data or the Facebook page or the login page is coming from it, right? So it is a concept, right? We use domain names and there is a DNS resolver, right? So why this concept is important? To just understand the next service, which is Amazon Route 53. So Amazon Route 53 is a DNS web service. So it can help, you can create your own domains, right? You can register your own domains on Route 53. If you don't want to register your own domains, you can create your subdomains on it. Okay, and then it can help with DNS resolutions, right? So people can, if you have a domain over there, definitely it acts as a DNS resolver. So your domains get transferred, your DNS gets resolved to a specific IP addresses, right? So it's a, again, it gives developers and businesses a reliable way to route end users to internet applications hosted in AWS, right? Amazon Route 53 connects user requests to infrastructure running in AWS, right? It can route users to infrastructure outside of AWS as well. So, right. So the key point which we need to remember is, what is Route 53? Route 53 is the DNS web service which is being offered as a managed service from AWS. Okay. So this ends the module 4 for us. These are some additional resources which definitely, once the slide is shared, deck is shared, you can go through offline. Okay, so Priyadarshan, we are done with module 4, which is networking.
Yes. Yeah. Thank you very much, Ankit, for your continuous slides and providing all information. So everyone, we will catch up in 30 minutes or 40 minutes or so. Like 2 o'clock again, we will be back to
Sounds good.
continue with our further upcoming slides and concepts.
Okay,
Yeah.
thanks,
So
Priyadarshan.
I'll be starting the timer here.
Okay,
Yeah.
you should I stop my screen?
Yes.
Sharing screen?
Yes. You can stop.
Okay, perfect. Okay.
Okay.